An online retail company suffers a data breach, resulting in the theft of customer credit card information. The compromised data is used for financial fraud, causing significant losses for customers. What steps will you take as an Azure security engineer to safeguard your data? Hello, and welcome to Secure Your Data at Rest, the fifth course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course will teach you to secure data using Azure and other Microsoft solutions. My name is Ramanujam Srinivasan, and I have been a technologist for the last 25 years. I'm a certified cloud and security architect and help Fortune 500 companies formulate strategies and implement security solutions. I'll be guiding you through this course. We have organized the course content into 5 weeks. Let's start with a high-level view of what you will learn. In the first week, you will learn about storage security. The second week delves into Azure Storage and Azure Files. During the third week, you will learn about database security and monitoring. Week 4 covers Defender for Cloud and also data masking and encryption. Finally, in the fifth week, you will do a project based on a real-life scenario and take a course-level graded assessment. Now let's dive deeper into each week. In the first week, you will learn what storage security is. You will also learn how data sovereignty is achieved in Azure. Data sovereignty refers to having control and ownership over one's own data. You will learn how to deploy shared access signatures, also called SAS. In addition, you will also understand how to generate and test SAS tokens. Next, you will learn about shared keys, managing storage account access keys, and key rollover. Finally, you will understand how to create stored access policies. Let's look at the hands-on exercises. This week, you will practice generating SAS tokens, testing key rollover, and creating stored access policies. As you progress into the second week, you will learn to manage Azure Active Directory Storage Authentication, also called Azure AD Storage Authentication. You will also learn to configure Azure AD User Account Authentication for storage. Then you will learn to implement storage service encryption. You will compare storage for file shares and blob data. You will also learn to configure blob data retention policies and authentication of Azure files. What else is coming your way in the second week? You will learn to enable the secure transfer required property and explore storage security configurations. In this week, you will practice configuring Azure AD user account authentication for storage and securing storage endpoints. In the third week, you will learn to configure which users and applications can access your structured query language databases, also called SQL databases. You will enable SQL database authentication and configure Azure AD authentication. You will also learn how to block access to your servers using SQL database firewalls. You will learn how to discover, classify, and audit the use of your data. You will understand how to monitor your database for malicious activity. There's more coming your way. You will learn to encrypt and protect your data while it is stored in the database. You will also gain an understanding of vulnerability assessments, data discovery and classification, and auditing. Don't miss the chance for hands-on activities. This week, you can practice configuring Azure AD authentication and securing an Azure SQL database. Let's dive into the fourth week now. This week, you will gain an understanding of Defender for Cloud and how it protects and secures hybrid cloud environments. You will learn about its features and suitable implementation. You will learn to enable Defender for SQL for advanced threat protection. Then you will learn how to use data encryption, data masking, firewalls, and auditing to protect databases from attacks. What else is in store? You will learn to secure your data in transit, at rest, and on display. Next, you will learn to configure dynamic data masking and implement transparent data encryption. In addition, you will learn about an Always Encrypted implementation. You will practice enabling Defender for SQL. You will also deploy an Always Encrypted implementation. That was a lot. The fifth and the last week will give you an opportunity to refresh your knowledge of the important concepts learned in the course through a course summary. Following this, we will present you with a real-life case study where you will step into the role of an Azure security engineer and perform activities related to securing data. Then you will take a course-level graded assessment, which will mimic the format of the AZ-500 exam. Are you excited to explore these topics further? Keep progressing through the rest of the readings and videos in this course. You will steadily advance towards your goal of becoming a Microsoft Azure Security Engineer Associate. Imagine you have a valuable collection of rare and expensive artifacts. Wouldn't you opt for a high security facility to store these artifacts? Similarly, data is one of the most important artifacts in today's digital world. How will you secure the location where data is stored? Hello, and welcome to the video, What is Storage Security? In this video, you will learn about storage security and how it fits into the defense in depth strategy. Defense in depth strategy is a comprehensive approach to information security that involves layering multiple security measures to protect against various threats. One of these layers is storage security. By securing storage, you can ensure confidentiality, integrity, and availability of your organization's data, mitigating risks such as unauthorized access, data breaches, and data loss. As an Azure security engineer, you will perform tasks such as locking down access to storage for specific users and applications. You will encrypt data in its storage location and during its transfer. You may use identity to protect data when it is accessed and used. You will protect data at rest, in transit, and while being used within an application. What will you learn about storage security this week? You will understand data sovereignty and how it is achieved in Azure. You will also learn to configure Azure Storage Access and create storage access policies. Next, you will learn to deploy shared access signatures, also called SAS. You will also learn to manage storage account access keys and key rollover. Azure provides several features to implement storage security. These encompass encryption, firewalls, and virtual networks, providing robust data protection. Additionally, Azure supports role-based access controls, also called RBAC, SAS, and monitoring and logging capabilities. These features empower you to enforce access permissions, securely share data, and monitor storage activity. Let's first look at encryption. Azure Storage Service Encryption enables automatic encryption of data while at rest in Azure Blob Storage or Azure Files. It uses 256-bit advanced encryption standard encryption and Microsoft managed keys. Consider a situation where a company stores financial records in Azure Blob Storage. With Azure Storage Service Encryption enabled, the data is automatically encrypted while at rest, ensuring that the financial records remain protected even if the storage medium is compromised. Now let's understand firewalls and virtual networks. You can configure Azure storage accounts with firewall rules to control access to data from specific IP addresses or network ranges. Additionally, you can use virtual networks to restrict access to your storage accounts by allowing traffic only from specific virtual networks or subnets. Imagine a company that stores sensitive customer data in Azure storage accounts. To enhance the security of the data, they configure firewall rules within the storage accounts. They specify that only specific IP addresses or network ranges associated with their trusted partners or internal systems are allowed access to the data. Next, let's look at RBAC. RBAC allows you to grant specific permission to users or groups, ensuring only authorized users can access your data. Consider a scenario where a company has multiple departments. Through RBAC, the company can grant permissions such as read-only or write access to specific roles such as data analyst or manager. The next feature is SAS. SAS provides a secure way of sharing data in Azure Storage without giving out your account key. It allows you to grant limited time access to a specific container or object with customizable permissions and policies. Consider a scenario where a software development company must securely share a software package with a client. Instead of sharing their Azure Storage account key, they generate a SAS token with a specific expiration time and grant the client access to a designated container. The SAS token is configured to allow the client to download the package without modifying or deleting any other files within the container. How does Azure help in monitoring and logging? Azure provides auditing logs for all activities performed on your storage account. You can use these logs for forensic analysis and compliance reporting purposes. Let's examine two more storage security concepts: management plane and data plane security. Management plane security refers to securing the management operations and administrative access to Azure storage resources. It involves implementing strong authentication, access control, and monitoring mechanisms to protect against unauthorized access and ensure proper governance. Data plane security focuses on protecting the data objects, such as blobs, stored within Azure storage accounts. You achieve data plane security using features such as storage account keys and shared access signatures. In this video, you learned about storage security, a layer of protection in defense in depth strategy. You learned about implementing storage security through encryption, firewalls, virtual networks, RBAC, and SaaS. In addition, you learned that you could use auditing logs for monitoring and logging. You learned that you could control the operations on data through management plane security and access to data itself through data plane security.
Consider that your organization operates globally, collecting and storing customer data from different countries. This data is processed in various Azure data centers. As per the regulations followed by certain countries, you must have these data centers within the country's borders. Failure to address these regulations can result in legal penalties. Did you know that these types of regulations are called data sovereignty regulations? Hello, and welcome to the video, Define Data Sovereignty. In this video, you will learn what data sovereignty is and how it is achieved in Azure. Data sovereignty is the concept that information, converted and stored in binary digital form, is subject to the laws of the country or region in which it is located. Let's take an example of a multinational e-commerce company that operates in the United States, Canada, and the European Union, also called the EU. This company collects and stores customer data, such as personal information. Each country has specific laws governing the storage and processing of personal data. For instance, the EU has implemented the General Data Protection Regulation, also called GDPR, which requires that the personal data of EU citizens must remain within the EU borders. GDPR ensures privacy and safeguards individuals' rights. The government of a foreign country or region may attempt to access data stored within its jurisdiction, even if the data belongs to individuals or organizations from another country. Enforcing privacy regulations and preventing the host country or region's government from accessing data are key concerns associated with data sovereignty. How does Azure address data sovereignty? Azure has data centers worldwide. An Azure region is an area within a geography containing one or more data centers. An Azure geography is a defined area of the world that has at least one Azure region. Each Azure region is paired with another region within the same geography, forming a regional pair. The exception is Brazil South, which is paired with a region outside its geography. In Azure, customer data is primarily replicated within a selected geographic area. This replication enhances data durability in the event of a major data center disaster. However, there are situations where you may decide to replicate data outside of the specific geographic area. We recommend configuring business continuity and disaster recovery, also known as BCDR, across regional pairs to benefit from Azure's isolation and virtual machine policies. It is also a good practice to use both regions in a region pair for applications that support multiple active regions. Multiple regions ensure optimal application availability and minimize disaster recovery time. Let's look at the benefits of Azure paired regions. The benefits include physical isolation, platform-provided replication, region recovery order, sequential updates, and data residency. First, let's look at physical isolation. Physical isolation involves separating data centers by a significant distance. Azure provides at least 300 miles of separation between data centers in a regional pair when possible. Long distance, however, may not be practical or possible in all geographies. Physical data center separation reduces the likelihood of both regions being affected simultaneously due to natural disasters, civil unrest, power outages, or physical network outages. Geographical factors influence physical isolation, including geography size, power, and network infrastructure availability and regulations. The next benefit is platform-provided replication. Azure provides replication options, such as the geo-redundant storage option, for replicating your data to a secondary region. This option allows automatic replication of your data to the paired region to protect against regional outages. The next benefit is region recovery order. If an outage occurs, recovery of one region is prioritized out of every pair. Applications deployed across paired regions are guaranteed to have one of the regions recovered with priority. If you deploy an application across regions that are not paired, it might delay recovery. In the worst case, the chosen regions might be the last two to be recovered. Now let's understand sequential updates. Planned Azure system updates are rolled out to paired regions sequentially, not simultaneously. A staged rollout helps minimize downtime, the impact of bugs, and logical failures in the rare event of a bad update. Data residency is another benefit of Azure paired regions. To meet data residency requirements for tax and law enforcement jurisdiction purposes, a region resides within the same geography as its pair, except for Brazil South. Let's summarize what you learned. In this video, you learned that data sovereignty is a concept that digital information is subject to the laws of the country or region in which it is located. Azure implements data sovereignty through Azure paired regions, providing multiple benefits such as physical isolation, platform-provided replication, region recovery order, sequential updates, and data residency. Consider that your organization relies on Azure Storage to store and manage sensitive customer information. You want to implement a secure authorization process to avoid the risks associated with unauthorized access. Hello, and welcome to the video Overview of Azure Storage Access. In this video, you will learn how to configure Azure Storage Access in a secure and managed way. Azure Storage has 4 services: Azure Blob Storage, Azure Files, Azure Queue Storage, and Azure Table Storage. You must ensure that every request made against resources secured in these is authorized to provide access only when required and only to the right users or applications. Clients access data stored in Azure Storage via Hypertext Transfer Protocol, also called HTTP, or Hypertext Transfer Protocol Secure, also called HTTPS. When a client requests data access, Azure does authorization checks to ensure the client has the necessary permissions to access the requested data. Let's look at the options for authorizing requests to Azure Storage. These include shared keys, shared access signatures, also called SAS, and Azure Active Directory, also called Azure AD. The options also include Azure AD Domain Services, also called Azure ADDS, and Public Access. To begin, we will delve into shared keys. In Azure Storage, when you create a storage account, 2 512-bit access keys are automatically generated. These keys are known as shared keys. You share these keys to grant clients access to the storage account. These keys grant root-level access. The shared key authorization process involves utilizing your account access keys and additional parameters to generate an encrypted signature string. This string is then included in the authorization header of the request being made to an Azure service. Another option for authorizing requests to Azure Storage is SAS. Using SAS, you can provide granular access to files in Azure Storage, such as read-only or read-write access. When creating a SAS, you can specify various options you can control. These options include start time, expiry time, and permissions. You can provide SAS to clients to delegate access to specific storage account resources when you do not trust these clients with your storage account key. By distributing a SAS Uniform Resource Identifier, also called URI, you can grant clients access to a resource for a specified period and with specified permissions. The SAS token's URI query parameters incorporate all the information necessary to grant controlled access to a storage resource. A client possessing the SaaS can request Azure Storage with just the SaaS URI. Azure Storage supports 3 types of SaaS: User Delegation SaaS, Service SaaS, and Account SaaS. You can use User Delegation SaaS only for blob storage. This SaaS is secured with Azure AD credentials. A Service SaaS is used to delegate access to a resource in any of the 4 Azure Storage services. A Service SaaS is secured using a storage account key. The only way to revoke or change a SaaS is to change the storage account keys. However, there's an option to associate SaaS with a stored access policy. A stored account policy can be associated with up to 5 active SaaS. You can control access and expiration at the stored access policy level. Using the stored access policy is a good approach to granting granular control to change the expiry date or revoke SaaS. An account SaaS has the same controls as a service SaaS, but can also control access to service-level operations, such as get service stats. It is secured with a storage account key. Now, let's look at Azure AD, another option for authorizing requests to Azure Storage. Azure Storage integrates with Azure AD to enable identity-based authorization of requests. You use Azure AD authorization for blob and queue services. With Azure AD, you can use role-based access control to grant access to blob and queue resources to users, groups, or applications. You can grant permissions at the container or queue level. Azure AD authorization takes a 2-step approach. First, you authenticate a security principal that returns an OAuth 2.0 token if successful. This token is then passed to Azure Storage to enable authorization for the requested resource. Authorizing access to blob and queue data with Azure AD provides superior security and ease of use over other authorization options. When you use Azure AD to authorize requests made from your applications, you avoid having to store your account access key with your code, as you do with shared keys. While you can continue to use shared keys with your blob and queue applications, Microsoft recommends moving to Azure AD where possible. Azure AD offers similar capabilities to SaaS without the need to manage SaaS tokens or worry about revoking a compromised SaaS. Azure AD DS, the next authorization option, is for Azure Files. Azure AD DS enables identity-based authorization over server message block in Azure Files. You can use role-based access control to provide fine-grained control over Azure Files resources in a storage account. Now, let's explore public access as an option to authorize Azure Storage requests. You can provide anonymous read access to a container and its blobs in Azure Blob Storage. Public access allows you to grant read-only access without sharing your account key or requiring a SaaS. Public read access is best when you want certain blobs to always be available for anonymous read access. You can still use SaaS for more fine-grained access control. 2 settings affect public access: the storage account and the container. Configure the storage account to allow public access by setting the Allow Blob Public Access property to True. Note that you must also set public access for the container. A container has 2 possible settings for public access: public read access for blobs, or public read access for a container and its blobs. You can manage access for anonymous users at the container level, not for individual blobs. To protect specific files, you can place them in a separate container that does not allow public read access. You should set up 2 specific configurations to allow anonymous public access. First, configure the storage account itself for public access. Second, set the access level for the specific container to allow public access. The advantages of the public access option are that you don't need to share keys with clients who need access to your files. You also don't need to manage SaaS. In this video, you learned how to configure Azure Storage Access in a secure and managed way. You understood that you could provide secure access using authorization options, such as shared keys, SaaS, Azure AD, Azure AD DS, and public access. You learned that Microsoft recommends moving to Azure AD where possible. Consider that a media production company you work for uses Azure Storage to store and manage data. The company wants to distribute its latest film to a select group of partners for review. How will you restrict access only to authorized individuals and for a specified period? You can use Shared Access Signatures, also called SAS. Hello, and welcome to the video Shared Access Signatures. In this video, you will learn how to use SAS to define specific permissions, duration, and constraints for accessing resources in Azure Storage. You do not need to provide your clients with direct access to your storage account credentials when you use SAS. Let's now understand how SAS works. SAS has two components: a Uniform Resource Identifier, also called URI, that points to one or more storage resources, and a token that defines how the client may access the resources. You will use query parameters in a SAS token to define the client access. Let's look at each of these. The SP parameter, which represents signed permission, indicates operations the client can perform. You can use the value of A for add, C for create, D for delete, L for list, R for read, and W for write. For example, SP equals R grants read-only access. You can also combine the values. The ST parameter represents start time. You can provide the date and time from when the resource can be accessed. The next parameter, SE, represents expiry time. You can provide the date and time when the access ends. The SPR parameter, which represents signed protocol, is an operational field. It indicates the protocol permitted for a request made with the SAS. By default, it considers both HTTPS and HTTP. The next parameter is SB, which represents signed version. You will use this parameter to mention the service version of the storage API to use. Another parameter you can use in the SAS token is SR, which represents scope of resource. You will use this to indicate the type of storage you want to access. You can use the value B for blob, C for container, D for directory, F for file, and S for share. The last parameter is SIG, which represents signature. This parameter is the cryptographic signature of the token. When you create a service or account SAS, the signature is signed with your storage account key. If you use an Azure Active Directory security principal with access to the storage, you create a user delegation SAS. In user delegation SAS, the signature is generated. You can include multiple query parameters in a SAS token by separating them with an ampersand sign. Each parameter value pair can be specified within the SAS token to define the desired permissions, resource types, and other access control settings. For example, SP equals R ampersand SR equals B would indicate that the client has read permission for a specific blob. Let's now understand how to create SAS in .NET. You will first create a blob container client to connect to the storage account on Azure. Then you will retrieve the blob you want to create a SAS token for and create a blob client. After this, you will create a blob SAS builder object for the blob you use to generate the SAS token. Then, authenticate a call to the toSASQueryParameters method of the blob SAS builder object. Now, let's look at some Microsoft recommended best practices to help you reduce the potential risks of using SAS. To securely distribute a SAS and help prevent man-in-the-middle attacks, always use HTTPS. The most secure SAS is user delegation. You should use it wherever possible because it removes the need to store your storage account key in code. You should use Azure Active Directory, also called Azure AD, to manage credentials. However, utilizing Azure AD for credentials might not be feasible in all situations. Another good practice is to set your expiration time to the smallest useful value. If a SAS key becomes compromised, it can only be exploited briefly. Apply the rule of minimum required privileges. Only grant the access that is required. There are some situations where SAS isn't the correct solution. When there is an unacceptable risk of using a SaaS, create a middle-tier service to manage users and their access to storage. The most flexible and secure way to use a service or account SaaS is to associate the SaaS tokens with a stored access policy. In this video, you learned how SaaS works. You learned about the query parameters used in SaaS. You also learned how you can use code to create SaaS. Finally, you learned the best practices to reduce the potential risks of using SaaS. Consider that you are an Azure security engineer in a healthcare organization. To enhance the patient experience, your organization has partnered with a company to develop a mobile app. You decide to provide the required data access using shared access signatures, also called SaaS. How will you deploy SaaS? Hello, and welcome to the video, Deploy Shared Access Signatures. In this video, you will learn about the types of SaaS and the deployment of SaaS. A SaaS is a string that contains a security token that can be attached to a Uniform Resource Identifier, also called URI. SaaS allows you to delegate access to storage objects, giving you the flexibility to define constraints such as permissions and the duration of access. Let's take an example. You can provide a customer with a SaaS token to securely upload pictures to a file system in blob storage. Additionally, you can issue a web application a separate SaaS token, granting it read access to those pictures. In both cases, you grant only the necessary access for the specific task. There are three types of SaaS. There are service-level SaaS, account-level SaaS, and user delegation SaaS. You can use a service-level SaaS to allow access to specific resources in a storage account. For example, you will use service-level SaaS to enable an app to retrieve a list of files in a file system or to download a file. Moreover, a service-level SaaS can reference a stored access policy that provides additional control over a set of signatures, including modifying or revoking access to the resource. An account-level SaaS allows access to anything a service-level SaaS can allow, plus additional resources and abilities. For example, you can use an account-level SaaS to allow the creation of file systems. A user delegation SaaS is secured with Azure Active Directory credentials. This type of SaaS is supported only for the blob service and can be used to grant access to containers and blobs. You would typically use SaaS for a service where users read and write their data to your storage account. There are two prevalent designs for accounts that store user data. In the first design, clients upload and download data through a front-end proxy service, which performs authentication. This front-end proxy service has the advantage of allowing the validation of business rules. However, if the service must handle large amounts of data or high-volume transactions, it might be complicated or expensive to scale this service to match the demand. In the second design, a lightweight service authenticates the client as needed. Then it generates a SaaS. After receiving the SaaS, the client can access to storage account resources directly. The SaaS defines the client's permissions and access interval. The SaaS reduces the need to route all data through the front-end proxy service. Let's now summarize what you learned. In this video, you learned about the three types of SaaS: service-level SaaS, account-level SaaS, and user delegation SaaS. You understood you could use stored access policies with a service-level SaaS for additional control. You also learned about deploying SaaS. Consider a scenario where a cloud administrator in your organization is responsible for managing and configuring an Azure Storage account. The administrator must perform tasks such as creating and managing containers, managing access policies, and performing account-level operations. How will you provide unrestricted access to the entire storage account? Hello, and welcome to the video, What are shared keys? In this video, you will learn what shared keys are and how to use them to authorize requests to a storage account. When you create a storage account in Azure, Azure automatically generates two access keys. These keys are known as shared keys or storage account access keys. These keys consist of a primary access key and a secondary access key, which provide equal privileges. You can use them interchangeably to authenticate and authorize requests made to the storage account. When making a request to the Azure Storage account, The client includes the shared key as part of the request headers or query parameters. The server then verifies the shared key and grants access. Using the shared key, you can authenticate and enable access to the entire storage account and all its resources, such as containers, blobs, tables, and queues. Remember that securing and protecting these shared keys is essential, as they provide unrestricted access to a storage account's configuration and data. How will you do this? You can manage shared keys through Azure Key Vault, which securely stores cryptographic keys and secrets. With Azure Key Vault, you can effectively control access to the shared key using role-based access control. You must safeguard access to the shared keys. To protect access, avoid hard-coding shared keys or saving them anywhere in plain text accessible to others. Additionally, you must rotate your keys if you believe they might have been compromised. You can take steps to prevent accidental use of the shared key. For this, you can disable shared key access when it is not required. When you disable shared key access, Azure provides alternative access methods, such as trusted access. Trusted access typically involves using other Azure resources or services, such as Azure Active Directory, also called Azure AD, to authenticate and authorize access to the storage account. Azure storage accounts generate diagnostic logs, which include information about the authorization methods used to access the storage account. Using more secure authentication and authorization methods, such as Azure AD authentication, shared access signatures, and managed identities, is a good practice. These options offer granular control and enhanced security compared to shared key authorization. Let's summarize. In this video, you learned that shared keys are access keys Azure automatically generates when you create a storage account. You understood that shared keys provide unrestricted access to a storage account's configuration and data. You also learned the importance of securing and protecting shared keys. As a best practice, provide granular data access with the least privileges. Imagine a company that uses Azure to host its applications and services. These applications rely on access keys for authentication and authorization when interacting with various Azure services, such as databases and storage accounts. These applications are evolving, and access keys are getting updated. Testing the new keys with the updated application is crucial to verify that the authentication and authorization work well. Hello, and welcome to the video Test Key Rollover. In this video, you will learn about key rollover and testing the key rollover to verify the successful implementation of the new keys. Key rollover is the process of replacing existing cryptographic keys with the new keys in a secure manner. You perform a key rollover to enhance security by mitigating the risks associated with long-term key usage. Key rollover can reduce the impact of key compromises and strengthen encryption algorithms. During a key rollover, you will generate new keys, update applications or services to use the new keys, transition from old to new keys, distribute the new keys as needed, and decommission the old keys. Testing the key rollover process ensures the new keys are properly generated, distributed, and applied without compromising system security. It helps identify any potential vulnerabilities or issues that may arise during the key rollover. Testing the new keys before full deployment ensures a smooth transition and minimizes potential disruptions. You can use Azure Storage Explorer to test key rollover. Azure Storage Explorer is a standalone application that provides a graphical user interface for managing and interacting with various Azure Storage services. It allows you to easily view and manage your data in Azure Blob Storage, Azure Files, Azure Queue Storage, and Azure Table Storage. To test key rollover, you will perform 4 steps. While performing these steps, you will use the Azure portal to fetch the access keys and Azure Storage Explorer to connect to a storage resource. First, you will download and install Azure Storage Explorer. Next, you will retrieve the existing key for a storage account from the Azure portal and connect to the Azure Storage account successfully using Azure Storage Explorer. As the third step, you will perform a key rollover in the Azure portal. To test the key rollover, you will try connecting to the storage account from the Azure Storage Explorer using the existing key. This step would fail as you have already performed a key rollover in the Azure portal. As part of the fourth step, you will fix this issue by going back to the Azure portal, copying the new key, and then using it to connect to the storage account. The connection would be successful as you have used the latest key. These steps summarize the activities to test a key rollover. Let's look at detailed instructions to test a key rollover for an existing storage account. You would first download and install Azure Storage Explorer. You can download it from the Azure portal or the Azure Storage Explorer download page on the Microsoft website. After installation, you will launch Azure Storage Explorer. You must enter your credentials if this is your first time using the tool. When you authenticate Azure Storage Explorer using your Azure account, you can select the Azure subscriptions associated with it to work with the corresponding storage accounts and their resources. Select and hold, or right-click, Storage Accounts and select Connect to Azure Storage. The Select Resource page in Azure Storage Explorer allows you to choose the specific Azure Storage resource you want to work with. By utilizing the options on this page, you can navigate through your Azure subscriptions, storage accounts, blob containers, file shares, queues, and tables to select the specific resource you want to manage or interact with using Azure Storage Explorer. For example, select Storage Account or Service to connect to a storage account. Next, you will select the connection method. As an example, let's select Account Name and Key. The Account Name and Key option allows you to connect to an Azure Storage account by providing the account's unique name and access key. You will fetch the information needed to connect by logging into the Azure portal and selecting your storage account. You can then select Access Keys to retrieve the storage account name and the key. You have the option to copy the storage account name and the access key. You can go back to Azure Storage Explorer, provide the account and key information, and select Next. Then, you will select Connect to navigate to your storage account. Let's now perform a key rollover. You will navigate to the portal, select your storage account, and then select Rotate Key. You will get a message that the current key will become immediately invalid and isn't recoverable. To confirm regenerating the access key, you would select Yes. The system will display the Successfully Regenerated Access Key message. In Azure Storage Explorer, you will refresh the storage account to access its contents. You will receive an error that the server failed to authenticate the request. The error is because you regenerated the key in the Azure portal, and now it does not match the key you previously used to access the storage account. Let's copy the latest key from the Azure portal and then connect to the storage account to test the key rollover. You will use the updated key to connect to the storage account in the Azure Storage Explorer. The next activity is to verify the details and select Connect. You can see that you can now access the storage account with the new credentials. Let's summarize what you learned. In this video, you learned about key rollover and its importance. You understood that testing a key rollover is important to ensure the new keys are properly generated, distributed, and applied without compromising system security. You also learned how to test a key rollover for an Azure Storage resource.
Consider that you are an Azure security engineer working in a healthcare organization. Your organization uses Azure Blob Storage to store sensitive patient data. To facilitate collaboration with external research institutions, you generate shared access signatures, also called SAS, for authorized researchers to access specific data sets. However, you encounter a situation where you need to revoke a researcher's access due to compliance concerns. Revoking the researcher's access would require regenerating the access keys, affecting all other active SAS. Using stored access policies, you can prevent disruption for other authorized researchers. Hello, and welcome to the video overview of stored access policies. In this video, you will learn about stored access policies and how they simplify permissions management and provide flexibility. Stored access policies in Azure offers an additional layer of control for SAS on the server side. They enable the grouping of SAS and provide more fine-grained restrictions for signatures governed by the policy. A stored access policy allows you to change a signature's start time, expiry time, or permissions. You can revoke a stored access policy after it has been issued. Let's understand the parameters of the stored access policy. The identifier parameter is the name you use to reference the stored access policy. Start time is a date-time offset value for the date and indicates when the policy becomes active. This value can be null. The expiry time parameter is a date-time offset value that indicates when the policy will expire. After this time, request to the storage will fail with a 403 error code message. The permissions parameter accepts a string that can include any combination of the ACDLRW permissions, allowing for a flexible list of permissions. In the string ACDLRW, the character A represents the permission to add, C represents the permission to change, and D represents the permission to delete. The character L represents the permissions to list or view, R represents the permission to read, and W represents the permission to write or update the resource content. You have three choices for how you specify these parameters. Firstly, you can include all the parameters in the signature's uniform resource indicator, also called URI, and not use the stored access policy. Alternatively, you can put all the parameters in the stored access policy and not include any in the URI. Lastly, you can mix parameters between the URI and the stored access policy. Please be aware that you must not indicate the same parameter in both the signature URI and the stored access policy. You can create a stored access policy on four types of storage resources: blob containers, file shares, queues, and tables. A stored access policy created for a blob container can be applied to both the container and its blobs. You can create a stored access policy with C# code, the Azure portal, or Azure command line interface commands, also called CLI commands. Let's first understand creating a stored access policy using C# code and applying it to a container called blob container. You can create a stored access policy by defining a blob signed identifier object with an identifier, an expiration time, and permissions. The policy is then applied to blob container using the set access policy method. Now let's look at how to create a stored access policy in the portal. Go to the storage account and the blob storage container in the portal. On the left, select Access Policy. To add a new stored access policy, select Add Policy. You can then enter all the required parameters. Let's understand creating a stored access policy using Azure CLI commands. The command AZ Storage Container Policy create is used to create a stored access policy for an Azure storage container. You then provide a unique name as an identifier and specify the name of the Azure storage container to which you will apply the stored access policy. In the next part of the code, you specify the start and expiry times. You can then specify the permissions granted by the stored access policy. Next, you specify the storage account key and the storage account name. After you create a stored access policy, you can reference the new stored access policy in the method that creates the SAS token. Let's take note of the three aspects regarding the creation of a stored access policy. First, you can have up to 5 stored access policies for a single blob container. Let's look at the second aspect. Creating a stored access policy on a container, table, queue, or file share may take up to 30 seconds for the policy to become active. During this time, requests made using a SAS associated with the stored access policy may fail with a status code of 403. The third aspect is that you cannot specify table entity range restrictions, such as the start partition key, also called start PK, in a stored access policy. Let's now understand how to modify or revoke a stored access policy. To modify the stored access policy parameters, you can call the access control list operation, also called ACL operation, for the resource type to replace the existing policy. For example, if your existing policy grants read and write permissions to a resource, you can modify it to grant only read permissions for all future requests. To revoke a stored access policy, rename it by changing the signed identifier, change the expiry time to a value in the past, or delete the stored access policy. Changing the signed identifier breaks the association between existing signatures and the stored access policy. Changing the expiry time to a value in the past causes any associated signatures to expire. Deleting or modifying the stored access policy immediately affects all the associated SAS. Call the resources set ACL operation to remove a single access policy, passing in the signed identifiers you wish to maintain on the container. Call the set ACL operation with an empty request body to remove all access policies from the resource. In this video, you learned what stored access policies are. You understood that stored access policies offer additional control for service-level SAS on the server side. You learned how to create stored access policies using C# code, Azure Portal, and Azure CLI commands. You then learned to associate stored access policies with SAS tokens. Finally, you learned to modify or revoke a stored access policy.
Imagine you are a cloud administrator at a software company. Your finance team needs to manage customer assets stored in an Azure Blob storage container. You are responsible for managing access to a Blob storage service in the cloud environment. Your task is to create a stored access policy to grant the finance team with read and list access to the container for a limited period of time. Let us learn how you will do that. Hello, and welcome to the video, Create Stored Access Policies. Here you will learn how to create a blob stored access policy by revisiting various concepts like shared access signatures and stored access policy. You will also learn how to modify or revoke a stored access policy. Let us start by quickly revisiting what we have learned about stored access policies. For that, let us redefine shared access signatures, also called SAS. A SAS is a safe and secure way to provide access to clients without having to share your Azure credentials. This benefit comes with the downside. Anyone who has access to the correct SAS can easily access the file while the SAS has validity. Coming back to the stored access policy, it provides an extra level of control over service-level SAS on the server side. And how does the stored access policy provide control? It groups SAS and provides more restrictions for signatures that are bound by the policy. You can use the stored access policy for various purposes, such as changing the start time, expiry time, or permission for a signature, or even revoke it after it has been issued. There are 4 storage resources that support stored access policies. They are blob containers, file shares, queues, and tables. Let us move on and understand how you can create a blob stored access policy. You can start by navigating to your blob container in the portal. Here, you can select Access Policy under the Settings blade. Here, you can review the 2 policies, that is, Stored Access Policies and Immutable Blob Storage. You can see the Add Policy option under Stored Access Policies. Select Add Policy. Here, you can look at various parameters such as the identifier, permissions, start time, expiry time options. Let us first learn about these properties. First, the identifier is the name you can use to reference the stored access policy. Next, start time is a value for the date and time when the policy might start to be used. This value can be left null. Then, expiry time is a value for the date and time when the policy expires. After this time, requests to the storage will fail with an error code message. Last, permissions is the list of permissions as a string. Moving on with the process, select the permission drop-down and create a policy with read and list permissions. Select OK. Enter the other required parameters. Back to the Access Policy page, select Add Policy under Immutable Blob Storage. Under Policy Type, you can review the 2 policy types, Time-Based Retention and Legal Hold. You can create a policy based on time-based retention. Make sure that you save your changes. Next, the stored access policy is added to your SAS. Note that you can have up to 5 stored access policies for a single blob container. You can also modify the stored access policy. To modify the parameters of the stored access policy, you can call the access control list operation for the resource type to replace the existing policy. For example, If your existing stored access policy grants read and list permissions to a resource, you can modify it to grant only read permission for all future requests. Moving on, if you want to revoke a stored access policy, you can delete it or rename it by changing the signed identifier. You can even change the expiry time to have a value from the past. Let us discuss these options in detail. Firstly, if you want to change the signed identifier, it breaks the associations between any existing signatures and the existing policy. Secondly, changing the expiry time to a value in the past will cause any associated signatures to expire. Lastly, deleting or modifying the stored access policy will immediately affect all the SaaS associated with it. With this, we have come to the end of this video. In this video, you revisited the concepts of SaaS and stored access policy. You learned how to create a blob stored access policy. Apart from this, you also learned how to modify a stored access policy. Other than that, you visited various options that can help you revoke the stored access policy. Well done! You learned a lot about storage security. You understood important concepts such as data sovereignty, shared access signatures, also called SaaS, shared keys, and stored access policies. Let's recap what you learned. First, you learned about data sovereignty. Data sovereignty is a concept that digital information is subject to the laws of the country or region in which it is located. You learned that Azure helps in addressing data sovereignty through its worldwide data centers. Azure implements data sovereignty via Azure paired regions, providing multiple benefits such as physical isolation, platform-provided replication, region recovery order, sequential updates, and data residency. What else did you learn? You learned about the various ways you can manage access to Azure Storage to provide access only when required and only to the right users or applications. You learned about shared keys, SaaS, Azure Active Directory, also called Azure AD, Azure AD Domain Services, also called Azure AD-DS, and public access. Shared keys grant root-level access to the storage account. SaaS allows you to specify various options to control access to the storage account. These options include start time, expiry time, and permissions. Azure Storage supports 3 types of SaaS: user delegation SaaS, service SaaS, and account SaaS. With Azure AD, you can use role-based access control to grant access to blob and queue resources to users, groups, or applications. You can grant permissions at the container or queue level. Azure AD-DS, the next authorization option, is for Azure Files. Azure AD-DS enables identity-based authorization over server message block in Azure Files. Public access allows you to grant read-only access without sharing your account key or requiring a SaaS. You learned that Microsoft recommends using Azure AD where possible. Let's get into the details of what you learned about SaaS. You learned that you could use query parameters in a SaaS token to define the client access. These parameters include SP for signed permission, ST for start time, SE for expiry time, SPR for signed protocol, SV for signed version, SR for the scope of resource, and SIG for signature. You learned that the most secure SaaS is user delegation SaaS. You understood that you should set the expiration time to the smallest useful value and apply the rule of minimum required privileges. You may have practiced what you learned through a hands-on exercise for generating SaaS tokens. Then you learned about shared keys. You learned that when you create a storage account in Azure, Azure automatically generates 2 access keys known as shared keys or storage account access keys. These keys consist of a primary access key and a secondary access key, which provide equal privileges. You can use them interchangeably to authenticate and authorize requests made to the storage account. You learned some best practices to safeguard access to the key. These include avoiding hard coding the keys, avoiding saving the keys in plain text, rotating keys if compromised, and disabling shared key access when not required. You learned that key rollover is the process of replacing existing cryptographic keys with new keys in a secure manner. You perform a key rollover to enhance security by mitigating the risks associated with long-term key usage. You understood the steps to test a key rollover. You learned that while performing these steps, you use the Azure portal to fetch an access key and Azure Storage Explorer to use the key to connect to a storage resource. What additional knowledge did you gain? You learned that using more secure authentication and authorization methods, such as Azure AD authentication and SaaS, is better than using shared keys whenever possible. These options offer granular control and enhanced security compared to shared key authorization. You may have practiced testing a key rollover through a hands-on exercise. Next, you learned that stored access policies in Azure offer an additional layer of control for SaaS on the server side. They enable the grouping of SaaS and provide more fine-grained restrictions for signatures governed by the policy. You learned about the parameters of a stored access policy, which include the identifier, start time, expiry time, and permissions. What else should you remember about stored access policies? You can have only up to 5 stored access policies for a blob container. Also, the policy takes up to 30 seconds to become active. You cannot specify table entity range restrictions in a stored access policy. You learned about modifying the stored access policy parameters, revoking a stored access policy, removing a single access policy, and removing all access policies. You may have practiced what you learned through a hands-on exercise to create stored access policies. You've accomplished so much. Now gear up for the graded assessment for this module. Good luck with the module quiz!
Imagine you're on the IT team at Protech Inc., a multinational software development company with development teams spread across different regions. Protech has a centralized Azure subscription where they store code repositories, artifacts, and other development assets in Azure Storage. It's been using shared access signatures, also called SAS, to grant temporary access to developers. However, due to challenges with SAS, including limited control over permissions and difficulties in managing access for the different teams, Protech has decided to implement Azure Active Directory, also called AD, storage authentication. Welcome to the video, Manage Azure AD Storage Authentication. In this video, we'll explore how organizations can manage and leverage Azure AD Storage Authentication, review the benefits of Azure AD Storage Authentication, and discuss key individuals and teams responsible for managing Azure AD Storage Authentication. How can organizations like Protech leverage Azure AD Storage Authentication to streamline development processes and protect valuable assets stored in Azure Storage? Let's take a look. With Azure AD integration, organizations can manage access to Azure Storage resources from a central location and use Azure AD groups and RBAC to assign permissions based on roles and responsibilities. This centralized access management simplifies access and ensures consistency across storage accounts. Azure AD Storage Authentication provides fine-grained access control over access permissions for defining and assigning custom roles, enforcing the principle of least privilege and restricting access to sensitive resources. By leveraging Azure AD security features, organizations benefit from an enhanced security posture for resource storage, enforce multi-factor authentication (MFA) for user accounts, add an extra protection layer, monitor logs, and leverage capabilities to detect suspicious authentication activities. Azure AD Storage Authentication offers seamless collaboration functionality for external stakeholders. External developers or partners can be granted access to special storage resources using Azure AD-based access, eliminating the need to generate and share SAS tokens, thus ensuring secure access. Azure AD integrates with Azure Monitor and Azure AD audit logs, providing comprehensive auditing capabilities to track and monitor access events, conduct security audits, and investigate security or policy violations, helping meet compliance requirements. Azure Storage supports using Azure Active Directory AD to manage storage authentication. Not only that, it also supports blob data authorization requests. Blob is short for binary large object, a data type that can store binary data such as images, videos, and other multimedia. Azure AD authorization provides enhanced security and convenience compared to shared key and SAS authorization, while ensuring access with minimum required privileges. With Azure AD, unlike shared key or SAS, you can use Azure role-based access control, Azure RBAC, to grant users, groups, or applications permissions by authenticating them through Azure AD within Azure Storage. When a user or application tries to access a queue resource, the request goes through a two-step process. Authentication, the identity of the user or application is authenticated, and an OAuth 2.0 token is generated. Authorization. The token is included in the request to the queue service, which verifies the token and authorizes access to the requested resource based on the assigned Azure roles. Applications running within Azure entities like Azure VMs, virtual machine scale sets, or Azure functions can utilize managed identities for accessing queues. Both native and web applications can request authorization using Azure AD when accessing the Azure Queue service. By leveraging Azure AD Storage authentication, you can enhance the security of your data, conveniently manage access permissions with Azure RBAC, and capitalize on features for more granular access control. Who's responsible for managing Azure AD Storage authentication? Typically, managing Azure AD Storage authentication falls under the purview of an IT operations team. Dedicated Identity and Access Management (IAM) team, or security officers and administrators responsible for managing the organization's overall infrastructure, security, and access control. Let's explore some of them. The IT operations manager oversees the overall infrastructure and technology operations, providing strategic direction to ensure appropriate management and security of the company's storage resources. An IAM administrator manages user identities, access, and authentication, and handles the configuration and administration of Azure AD, including integrating Azure AD with Azure Storage and managing access and permissions for storage resources. Chief Information Security Officer, also called CISO, plays a crucial role in ensuring data and resource security, working closely with the IT operations and IAM teams to establish security policies, enforce best practices, and mitigate security threats. Development team leads collaborate with the IAM team to define access requirements for their respective teams, ensuring smooth development workflows. They provide input about their team members' specific access needs. Azure administrators configure and manage Azure resources, including Azure Storage and Azure AD integration. They work closely with the IAM administrator to ensure the proper functioning of the Azure AD Storage authentication. As you can see, the responsible individuals and teams collaborate to define access control policies, set up the integration, configure roles and permissions, monitor access events and logs, and provide ongoing administration and support for Azure AD Storage authentication within an organization. Let's recap. In this video, you learned about Azure AD Storage authentication management and its benefits. By implementing Azure AD Storage authentication, you discovered that organizations could streamline development processes and protect valuable assets stored in Azure Storage. Benefits include centralized access management, fine-grained access control, enhanced security features, seamless collaboration, comprehensive auditing capabilities. You also learned about the key individuals and teams responsible for managing Azure AD Storage authentication, including IT operations, IAM administrators, security officers, development team leads, and Azure administrators. Imagine you're an Azure security engineer for Titan Health Tech, specializing in healthcare software solutions and developing advanced electronic health record (EHR) systems. Data security is a top priority. Given the sensitive nature of healthcare data, you opt for Azure as their cloud solution, and to further enhance security, decide to implement Azure Storage Service Encryption. Implementing Storage Service Encryption brings numerous benefits, including enhanced security with automatic encryption of all data at rest and protocols. Securing data in transit, the EHR system data remains secure from potential breaches. Compliance. The healthcare sector deals with sensitive personal data, subject to strict regulatory requirements like HIPAA. Using Azure Storage Service Encryption, which is FIPS 140-2 compliant, helps meet these regulatory requirements. Controlled access. Azure AD and RBAC can efficiently manage and control who has access to what data, minimizing the risk of unauthorized data access. Cost-efficient, since there's no additional cost for Azure Storage Service Encryption. Robust security is available without incurring extra expenses. Performance. Azure Storage Service Encryption does not affect the performance of storage services, which ensures the EHR system continues to operate at peak efficiency without any slowdowns. Welcome to the video, Implement Storage Service Encryption. In this video, we'll explore Storage Service Encryption, its uses and benefits. Azure Storage Service Encryption plays a vital role in keeping your data safe. Here's how the advanced security features of this key part of defense in-depth strategy work together to protect your data. Automatic encryption. Any data you store in Azure, including metadata, is automatically encrypted. Storage Service Encryption, giving you peace of mind about your data's security. Access control. Azure Active Directory, Azure AD, and role-based access control, RBAC, allow you to control who can access and manage stored data. For example, you can use RBAC roles to authorize operations like key management and Azure AD for data operations. Data security in transit. Your data is protected when it moves between your application and Azure, using protocols like client-side encryption, HTTPS, or SMB 3.0. Disk encryption. You can also encrypt the OS and data disks used by Azure virtual machines through Azure Disk Encryption. Delegated access. Access to your data in Azure Storage can be shared through a shared access signature. Azure Storage Service Encryption provides automatic encryption for data at rest. It ensures your data is secure when stored in the cloud, and it's automatically encrypted using 256-bit AES encryption, a powerful block cipher. The process is transparent and FIPS 140-2 compliant, similar to BitLocker encryption on Windows. Automatic encryption is always enabled, so there's no need to change code or applications to use Azure Storage encryption. All your Azure Storage resources, including blobs, disks, files, queues, tables, and metadata, are encrypted. Don't worry, encryption won't slow down Azure Storage, and there are no additional charges. There are a few key encryption management options for encrypting storage accounts. You could opt for Microsoft Managed Keys or manage your key encryption. There are two choices if you opt for self-management. You can designate a key that you manage yourself to encrypt and decrypt all data within your storage account. This customer-managed key is employed across all your storage account services to ensure comprehensive data encryption. For blob storage operations, you can specify a customer-provided key, which allows any client making a read or write request to blob storage to incorporate an encryption key into their request, offering precise encryption and decryption control. Let's return to Titan Health Tech for more details about storage service encryption. Titan Health Tech opts for Azure's automatic encryption for all data at rest to maximize security. Health records or metadata written to Azure Storage are automatically encrypted using 256-bit AES encryption, providing robust protection. They use Azure AD and role-based access control, RBAC, to manage data access. The developer team, system admins, and other personnel are given access based on role and job performance needs. They implement client-side encryption, HTTPS, and SMB 3.0 protocols for data in transit, ensuring the secure movement of healthcare records between the application and Azure. Titan Health Tech also encrypts OS and data disks used by Azure virtual machines with Azure Disk Encryption. And for temporary access or access with specific permissions to their data, they use Azure's shared access signature. For encryption key management, Titan Health Tech decides to manage the keys themselves. Using Azure Key Vault, self-management allows them to rotate, manage, and control their own encryption keys. By implementing storage service encryption, Titan Health Tech can provide its clients with a secure, efficient, and compliant EHR system. Let's review. In this video, you learned about implementing storage service encryption. You discovered that Azure Storage Service Encryption provides several benefits, including enhanced data security for both at-rest and in-transit data, compliance with regulations like HIPAA, controlled access to data via Azure AD and RBAC, cost efficiency, and maintaining peak operational performance since encryption doesn't slow the services. And you learned about the key management options for Azure Storage Service Encryption, including using Microsoft Managed Keys or self-managing encryption, using either a customer-managed key for encrypting all data in the storage account or a customer-provided key for granular control over blob storage operations. An appropriately configured blob retention policy is vital for optimizing Azure Storage Service in line with the organization's operational needs, cost control efforts, and regulatory compliance requirements. Let's find out more. Welcome to the video, Configure Blob Data Retention Policies. In this video, you'll gain practical insights into Azure Blob Data Retention Policies, discover how to meet regulatory compliance requirements, and explore the pivotal role retention policies play in data management, governance, and security. Meet John, an IT manager at TechMed Innovations, a healthcare technology startup. He receives an email from the legal team asking him to ensure that all patient health data stored in their Azure Blob Storage environment is retained for at least 7 years to comply with new healthcare industry regulations. The data, including medical records and laboratory results, should remain accessible for reading but cannot be modified or deleted during this period. John consults Maria, a cloud solutions architect at TechMed Innovations, about complying with these regulatory requirements. Maria, responsible for managing the Azure environment, suggests setting up time-based retention policies using Azure's immutable storage for their blob storage accounts. With time-based retention policies, TechMed can store data in a write once, read many worm state, meaning that data can be read multiple times but not altered or deleted for a predetermined period. Once the retention period is over, the data can be deleted but not altered. If this policy is applied to a container, all data will remain unchanged for the set retention period. This period is calculated as the difference between when the data was created and the set retention period. Should there be a need to increase the retention period, the system will calculate this new value. After applying the time-based retention policy to containers storing patient health data, TechMed set a retention period of 7 years, ensuring that data in these containers are stored in an immutable state for this duration. However, TechMed Innovations is also currently involved in a legal case, so Maria decides to set a legal hold policy on certain blobs that might serve as crucial evidence. She attaches a unique alphanumeric tag, like a case ID or event name, to easily identify the blobs associated with the case ID. Legal holds are typically used for legal proceedings or general protection policies. Each legal hold policy must be associated with one or more tags. Maria ensures that the audit logging feature is enabled to monitor operations, maintain a record of policy-related actions, provide a safety net for the company, and ensure regulatory compliance. Policy audit logs for each container display commands related to locked time-based retention policies, user ID, command type, timestamps, and retention period. For legal holds, command displays include the user ID, command type, timestamps, and legal hold tags. According to SEC 17A-4F guidelines, this log is kept for the policy's lifetime. Azure Activity Logs provides a more detailed log of all control plane activities. Azure Resource Logs shows data plane operations. Worm policies are not limited to a specific Azure Blob storage tier and support all blob tiers, hot, cool, and archive. So TechMed can move its data to the most cost-effective tier while ensuring it remains unchanged. As mentioned earlier, TechMed can also take advantage of container-level configuration. They can create and lock retention policies, extend retention periods, and set and clear legal holds, among other things. These policies apply to all data in their container, whether existing or new. So TechMed Innovations can ensure regulatory compliance, immutability, and retention for business and legal needs by configuring Azure Blob data retention policies. Blob data retention policies are also vital to data management and governance for several other reasons. Let's take a look. Crucial for data protection and disaster recovery scenarios. Retention policies allow you to specify how long data should be kept before automatically deleting. In case of accidental deletion or alteration, the blob-level data can be restored to a point within the retention window. Retention policies ensure regulatory compliance with specific legal and regulation requirements, dictating how long certain types of data must be retained. Organizations can manage costs associated with Azure data storage by setting retention policies to remove older, unneeded data automatically. Retention policies are a core component of data lifecycle management, allowing automation of the data moving process to different storage tiers. Retention policies improve security posture by mitigating risks associated with data breaches. Refraining from retaining data longer than necessary potentially reduces the amount of data exposed in a breach. Let's recap. In this video, you learned about the importance and implementation of Azure Blob data retention policies. You saw how retention policies, particularly time-based and legal hold policies, help meet regulatory compliance requirements, ensuring immutable data is kept for a certain period. You explored how to apply these policies at the container level, the role of audit logs and tracking policy-related actions, and how retention policies contribute to data management, governance, cost control, and security. The Secure Transfer Required Property is a security feature in Azure Storage Services that mandates that all data sent to and retrieved from the storage account must be made over a secure HTTPS connection. The Secure Transfer Required Property should always be enabled when dealing with sensitive or confidential data. Welcome to the video, Enable the Secure Transfer Required Property. In this video, we'll discuss how the Secure Transfer Required Property mandates secure HTTPS connections for data transfers and enhances data security. We'll also look into the various means of enabling this vital security feature. For enhanced security, you can modify the Secure Transfer Required Property of your storage account to permit secure connections only, a modification strongly recommended by Microsoft. This setting rejects any requests made from non-secure sources, thereby enhancing your data security. When the Secure Transfer Required setting is enabled, all Azure Storage REST API calls must be performed over HTTPS. Any attempts made via HTTP will be denied. Attempts to connect to an Azure file share over a server message block, also called SMB, without encryption will fail when secure transfer is required for the storage account. This point of failure includes insecure connections such as SMB 2.1, SMB 3.0 without encryption, and certain versions of the Linux SMB client. It's important to note that Azure file connections require SMB. Upon creating a storage account, the secure transfer required setting is activated by default. However, Azure Storage does not support HTTPS for custom domain names, so this requirement is not enforced when a custom domain name is utilized. This secure transfer setting does not apply to TCP. Connections via NFS 3.0 support protocol in Azure Blob Storage using TCP, which is not secured, will succeed. You can also enable the secure transfer required setting for existing storage accounts from code or with PowerShell. Let's explore more about the different ways to enable this security feature. Require secure transfer for a new storage account. Open the Create Storage Account pane in the Azure portal. On the Advanced page, select the Enable Secure Transfer checkbox. Require secure transfer for an existing storage account. Select an existing storage account in the Azure portal. In the Storage Account menu pane under Settings, select Configuration. Under Secure Transfer Required, select Enabled. Require secure transfer from code. To require secure transfer programmatically, set the Enable HTTPS Traffic Only property to True on the storage account. You can set this property by using the Storage Resource Provider REST API, client libraries, or other tools, including REST API, PowerShell, CLI, Node.js, .NET SDK, Python SDK, Ruby SDK. Require secure transfer with Azure AZ PowerShell. Microsoft recommends using the Azure AZ PowerShell module to interact with Azure. Requiring secure transfer in Azure using AZ PowerShell mandates all communications to a storage account be done via a secure HTTPS connection. The HTTPS setting aids in protecting your data during transmission from threats like man-in-the-middle attacks. It's essential to ensure that applications using your storage account can support HTTPS before enabling it to avoid disruptions. The AZ PowerShell command for this setting modification allows flexibility across multiple storage accounts and can be integrated into scripts for more automated and consistent configurations. Require secure transfer with Azure CLI. Azure CLI is a cross-platform tool, making it a versatile choice for mixed or non-Windows environments. When requiring secure transfer using the Azure CLI, you're implementing an extra layer of security in your Azure storage account, no matter which platform you're operating. Its commands are more consistent with other CLI tools, which might be more familiar or comfortable to those with a background in Unix or Linux systems. It offers similar security measures to AZ PowerShell by enforcing HTTPS for data communication, thereby safeguarding your data during transmission. Let's review. In this video, you learned about secure transfer required property features' critical role in enhancing data protection by facilitating only secure HTTPS connections for data transfers. We discussed Azure Storage REST API calls and SMB connections, and we explored enabling the secure transfer required property feature in new and existing storage accounts via the Azure portal and using coding tools including Azure AZ PowerShell and Azure CLI. Job well done. You made your way through Week 2, Azure Storage and Azure Files. During this week, you explored Azure AD, or Active Directory authentication for storage, and Azure Storage and Azure File Security. Let's recap what you worked on, shall we? You began by learning how to manage Azure AD storage authentication. You found that organizations could streamline development processes and protect valuable assets stored in Azure Storage by implementing Azure AD storage authentication. You explored the benefits including centralized access management, fine-grained access control, enhanced security features, seamless collaboration, comprehensive auditing capabilities. You learned who the key individuals and teams responsible for managing Azure AD storage authentication are, including IT operations, IAM, also called Identity and Access Management, administrators, security officers, development team leads, and Azure administrators. Next, you participated in a hands-on activity and put theory into practice by configuring an Azure AD user account authentication for storage. You completed the steps to test and configure an Azure AD user account authentication for storage. Following the activity, you explored implementing storage service encryption. You learned about the benefits, including enhanced data security for both at rest and in-transit data, compliance with regulations like HIPAA, controlled access to data via Azure AD and role-based access control, known as RBAC, cost efficiency, and continued peak operational performance since encryption doesn't slow the services. You discovered the key management options for Azure Storage Service Encryption, including using Microsoft-managed keys or self-managing encryption, using either a customer-managed key for encrypting all data in the storage account or a customer-provided key for granular control over blob storage operations. Then you learned how to configure blob data retention policies. You saw how retention policies, particularly time-based and legal hold policies, help meet regulatory compliance requirements, ensuring immutable data is kept for a specified period. You explored how to apply these policies at the container level, the role of audit logs in tracking policy-related actions, and how retention policies contribute to data management, governance, cost control, and security. After blob data retention, you found out how to enable the secure transfer required property, a security feature in Azure Storage Services that mandates that all data transferred to or from the storage account must be made over a secure HTTPS connection. The secure transfer required property should always be enabled when dealing with sensitive or confidential data. You learned about secure transfer required property features' critical role in enhancing data protection by facilitating only secure HTTPS connections. We discussed Azure Storage REST, also called representational state transfer, API calls, and SMB or server message block connections, including Azure AZ PowerShell and Azure CLI, also referred to as command line interface. And we explored enabling the secure transfer required property feature in new and existing storage accounts via the Azure portal and using coding tools, including Azure AZ PowerShell and Azure CLI. Finally, you participated in another hands-on exercise. You secured a storage endpoint and completed the following tasks: locate your storage account, create file share and upload a file, generate SAS, also called shared access signatures, and connection string. Use Storage Explorer and the connection string to access the file share. Under service endpoints, check Microsoft.storage option. Add a virtual network and verify your subnet with the new service endpoint is listed. Check Storage Explorer such that your file share can no longer be accessed. Congratulations, you're ready to complete the module quiz. You've got this. Once you complete the module quiz, you can move to Module 3, Database Security and Monitoring. Best of luck.
Azure Database Security encompasses all security measures Microsoft Azure takes to ensure that its customer data is kept safe and secure from unauthorized access, data breaches, and other malicious activities. Welcome to the video overview of database security. When we talk about Azure Database Security, it involves several concepts, including, but not limited to, firewalls, virtual network service endpoints, authentication, authorization, data encryption, threat detection, and auditing. Azure SQL Database, for instance, uses firewall at the server and database levels to protect the data. The server-level firewall rule allows traffic from specified IP addresses, while the database-level firewall allows access to specific databases. The combination of these two provides an added layer of security. Similarly, Azure Cosmos DB uses an IP firewall to control network access. Virtual network, VNet, service endpoints extend your VNet private address space and protect the identity of your VNet to Azure service resources, ensuring that only traffic from your VNet can access the databases. Azure supports a robust set of technologies for authenticating users who attempt to access Azure databases, including using Azure Active Directory for identity management and SQL authentication, which involves username and password combinations. Authorization in Azure databases is handled through RBAC, role-based access control, which provides fine-grained access management to Azure resources. It allows you to grant users the appropriate amount of access based on their role within your organization. Azure provides several encryption options to secure data at rest, in motion, and during processing. Transparent Data Encryption, TDE, encrypts SQL Server, Azure SQL Database, and Azure Synapse Analytics data files, preventing unauthorized access from the storage layer. Always Encrypted feature in SQL Server and Azure SQL Database helps to protect sensitive data such as credit card numbers or national identification numbers in transit and while in memory. Microsoft Defender for Identity formerly called Azure's Advanced Threat Protection, ATP, for databases, offers comprehensive monitoring and threat detection. It can identify unusual and potentially harmful attempts to access or exploit databases and will generate alerts for suspicious activities like SQL injection attacks, access from unique locations, and more. Auditing is another vital aspect of Azure database security. It tracks database events and writes them to an audit log in your Azure Storage account, log analytics workspace, or event hubs. Auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that could indicate business concerns or suspected security violations. Apart from these, Azure offers several other security measures like data masking, which obscures sensitive data in the database from non-privileged users. Private link allows access to your Azure SQL Database service over a private endpoint in your virtual network, ensuring secure connectivity. Azure continuously updates its services with the latest patches to ensure a safe database environment without user intervention. Furthermore, Microsoft Azure regularly undergoes several independent third-party audits to receive certifications, ensuring it meets global and regional compliance requirements. Imagine you are on an online vendor's IT team handling sensitive customer data, including phone numbers, home addresses, and credit card details. At the same time, you also manage critical business data such as financial records and proprietary intellectual property. The implications of this data falling into the wrong hands through malicious access or exposure are grave. Such an event can jeopardize business operations, trigger financial penalties, and shatter customers' trust in the brand. Therefore, a significant part of your responsibility is to ensure this data stored in databases is as secure as possible. Now imagine you are an attacker trying to breach a system. A system with a single layer of protection might be easily compromised. However, a system with multiple layers, where each layer is designed to protect the one beyond it, is significantly harder to infiltrate. This method is the principle of defense in depth, a strategy that employs a layered approach to slow down an attack aimed at acquiring unauthorized access to data. With its built-in security capabilities, Azure SQL Database enables you to adopt this defense in depth strategy. The service includes tools for configuring database firewalls, managing secure access, and encrypting communication between the database and applications. It even has sophisticated measures like threat detection and proactive security alerts through services like Microsoft Defender for Cloud for SQL. Let's review. In this video, you explored the multifaceted security features offered by Azure for its databases. We discussed firewalls and virtual network service endpoints, authentication and authorization, data encryption, threat detection, auditing, and other security measures. We also touched on the importance of regular updates and staying informed about continuous improvements in Azure to maintain a robust and secure database environment. We hear news about hackers and data breaches almost daily. Hence, it's essential to properly control and secure your database by granting permission access only to whom, where, and when necessary. Such control is made possible by Azure SQL Database's built-in functionality, which enables complete command over authentication and authorization of identities seeking to access database data. The importance of carefully controlling database access cannot be overstated for the following reasons. By implementing stringent access control, you ensure data security and integrity, helping prevent unauthorized access to your database, which can lead to data loss, theft, or manipulation. Proper access controls help meet today's compliance requirements, especially when dealing with personally identifiable information and education, financial, and health records. Data privacy is a critical concern today, and controlling database access is vital to ensuring privacy. Managing who has access to the database and what they can do helps maintain operational stability. Uncontrolled access to a database can lead to performance degradation, inadvertent errors, and downtime. Managing database access is not just about limiting who can get in, but also defining the actions they can perform. Adopting the principle of least privilege, where users have access to only the data, and resources required to perform their job is a fundamental best practice. Any potential damage is minimized if an account is compromised, helping keep your database secure and functioning as expected. Welcome to the video Control Who Can Access Your Database. In this video, you will learn about authentication, authorization, and the importance of controlling access. Let's get started. Authentication confirms the identity of a user, system-based service, or even an entire system to ensure that whoever or whatever is claiming a particular identity is genuine. SQL authentication and Azure AD authentication are the two types of authentication supported by SQL Database. SQL authentication relies on the traditional username and password method. You can create user accounts within the main database and grant them permissions across all server databases, or you can create user accounts in a specific database called contained users with access to only that database. Using the server admin login credentials you specified when you created the logical server, you can authenticate to any database on the server as the database owner or DBO. On the other hand, Azure AD authentication utilizes identities managed by Azure AD and is supported for managed and integrated domains. Azure AD authentication allows you to centrally manage database user identities and other Microsoft services from a single location. Central ID management simplifies database user and permission management and is a recommended best practice. However, if you want to use Azure AD authentication, you must create another server admin called the Azure AD admin. This admin can administer Azure AD users and groups and perform all operations that a regular server admin can. Authorization is the next step after authentication. It determines what actions an identity can perform within an Azure SQL database. Authorization is controlled by permissions granted directly to the user account or database role memberships. Database roles are a convenient way to group permissions for easier management. Users are added to roles to receive specific permissions, such as signing into the database, reading a table, or modifying the structure of a database. Both SQL and Azure AD users are granted authorization using the same process. Your application should use a dedicated account for authentication as a safety measure. This best practice limits permissions granted to the application, mitigating risks of unwanted activities if your application code is susceptible to a SQL injection attack. The recommended practice is to create a contained database user, allowing your application to authenticate directly to the database. It is also recommended to manage identities using Azure AD authentication centrally and as an alternative to SQL Server authentication. Let's recap. In this video, you learned the significance of controlling access to your database by establishing and managing user access. Some of the key points covered include the importance of controlling database access for ensuring data security and integrity, meeting compliance requirements, protecting privacy, and maintaining operational stability. Authentication as the process of verifying identity using SQL authentication, username and password, or Azure Active Directory, Azure AD, authentication, centralized identity management. Authorization as the process of assigning permissions and roles to an authenticated identity, then determining what actions they can perform within an Azure SQL database. Recommended best practices including applications using a dedicated account, creating contained database users, centrally managing database user identity using Azure AD.
Imagine an online e-commerce platform with millions of customers worldwide. To ensure a smooth user experience, they store customer data and inventory details in an Azure SQL, also known as a structured query language database. One day, a group of hackers attempted to access their database to steal customer information. However, they have SQL database authentication enabled, with strong unique passwords for each user account, which makes it significantly harder for unauthorized users to access their database. As a result, customer information remained secure, and the integrity of their platform was preserved. Welcome to the video, Enable SQL Database Authentication. In this video, we'll explore SQL Database Authentication, distinguishing between SQL and Azure AD authentication methods. We'll also touch on managing users and roles, the importance of minimum necessary permissions, and security features available in Azure SQL Database and Azure Managed Instance. Database security consists of two vital components: authentication and authorization. Authentication, like providing an ID to sign up for or pick up a package, validates identities when connecting to a database through the user's account. Proof of identity can be provided via SQL or Azure Active Directory authentication. On the other hand, authorization is like a VIP list at an exclusive event, managing the levels of access granted once authentication has been achieved. With SQL authentication, users enter their account name and password, a secret handshake known only to the user and the system. Since this password is connected to the user's account, it is kept safe in the master database. Passwords not connected to an account are kept in a secondary database. Azure Active Directory authentication asks users to provide an account name. Then, the system verifies their credentials from the secure Azure Active Directory. User accounts can be created in the master database, granting permissions across all databases or directly within a secondary database, referred to as contained database users, offering greater flexibility. In Azure SQL, you have logins and user accounts. A user account can be associated with a login stored in the master database or as just a username in a specific database. Logins are individual accounts. Although stored in the master database, they can be linked with multiple databases. User accounts don't need to be linked to a login and can be stored in any database. Credentials for user accounts not associated with a login are stored within the user's account. SQL database authentication verifies and permits users to access a database with usernames and passwords, providing an alternative to integrated authentication. SQL Server provides two security modes for authentication: Windows Authentication Mode, where users provide their Windows login credentials. Mixed Mode combines SQL Server and Windows Authentication Mode, permitting both SQL Server and Windows login. During setup, the SQL Server database engine can be configured for either mode. However, it can be adjusted post-installation. If Windows Authentication Mode is chosen, the System Administrator, SA, login is deactivated, and the installation generates a password. In Mixed Mode, the SA login connects to the server solely via SQL Server authentication, so you must use the alter login command to re-enable the SA login and assign a new password. Authorization, similar to a set of rules dictating permissions, is managed by your account's roles. Best practices recommend following the principle of least privilege and providing minimal access rights. And, for safer application interaction, use a dedicated account for authentication, potentially a contained database user, allowing direct database connection. Azure AD authentication provides a method to connect to Azure SQL Database, Managed Instance, and Azure Synapse Analytics using identities in Azure AD. It offers an alternative to SQL Server authentication, controlling user identity proliferation across database servers and simplifying password management. SQL Server authentication is the more traditional mode of authentication in SQL Server, and it's supported in Azure SQL Database and Managed Instance. Users and passwords are created within the database, and clients authenticate directly to the database. Before we wrap up, consider the following about Azure SQL Database and Managed Instance. When managing users and roles, it's important to understand how to create users, assign roles, include database-level and server-level roles, and manage permissions. You should be aware of the built-in security features, such as always-on transparent data encryption, auditing, and advanced threat protection, and how to configure server-level and database-level firewall rules to protect Azure SQL resources. Let's review. In this video, you learned about SQL database authentication, one of the key aspects of database security and authorization. You discovered the two methods of authentication: SQL authentication, which involves entering a username and password, and Azure AD authentication, where credentials are verified securely from Azure Active Directory. You explored the flexibility of creating user accounts in the master database, which grants permission across all databases or directly within specific databases. You also learned about the different security modes for authentication provided by SQL Server, best practices, including the principle of least privilege, and using the dedicated accounts for application interactions, and the functionality of Azure AD authentication. EasyShop, a rapidly growing online business, uses Azure SQL, also known as Structured Query Language, database for data management. They configured Azure SQL Database firewalls to help prevent data breaches. Such cyber threats can harm customer trust and the company's reputation. They implemented server-level IP, also called Internet Protocol, firewall rules, allowing only their servers to access the database and blocking potential threats. They enabled Azure connections for internal applications and restricted access to authorized personnel only. Database-level IP firewall rules were set for databases containing sensitive information, so even authorized database users can't access specific databases without additional clearance. With these firewalls, EasyShop concentrates on business growth while maintaining data security and limiting database access. Welcome to the video, Configure SQL Database Firewalls. In this video, we'll explore establishing server-level and database-level IP firewall rules for database access. Kicking off your database security measures begins with an SQL database firewall. Firewalls block access to your database server until you permit specific computers, ensuring data security. The firewall authorizes database access based on each request's originating IP address. Beyond IP rules, virtual network rules are also managed by the firewall. Virtual network rules are founded on virtual network service endpoints and may be a better choice than IP rules. Accessing your Azure SQL Database server requires using one or more server-level IP firewall rules. IP firewall rules identify which internet-based IP address ranges are permitted and whether Azure applications can try to connect to your Azure SQL Database. If you wish to grant selective access to a specific database in your Azure SQL Database, you'll need to generate a database-level rule for that particular database. Designate an IP address range for the database IP firewall rule that surpasses the IP address range stated in the server-level IP firewall rule. Be sure the client's IP address falls within the range specified by the database-level rule. During the connection process and rules verification, when a computer attempts an internet-based connection to your database server, the firewall initially checks the request's originating IP address against the database-level IP firewall rules for the requested database. Connection to the SQL database containing the rule is allowed if the request's IP address is within one of the ranges set in the database-level IP firewall rules. The firewall assesses server-level IP firewall rules if the request's IP address is not within one of the ranges set in the database-level IP firewall rules. Connection is allowed if the request's IP address is within one of the ranges specified in the server-level IP firewall rules. Server-level IP firewall rules apply to all SQL databases on the Azure SQL Database. Connection is only allowed if the request's IP address is within the range set by any database-level or server-level IP firewall rules. You must enable Azure Connections to permit Azure-based applications to connect to your Azure SQL Database. When an application from Azure tries to connect to your database server, the firewall verifies whether Azure connections are allowed. A firewall setting with start and end addresses set to o.o.o.o indicates that Azure connections are permitted. Choosing this firewall setting allows all connections from Azure, even from other customer subscriptions. If you select this option, ensure that sign-in and user permissions restrict access to only authorized users. Requests won't reach the Azure SQL Database server if the connection attempt is disallowed. Server-level IP firewall rules, stored in the master database, permit clients to access your entire Azure SQL Database, meaning all databases within the same SQL Database server. You can set up server-level IP firewall rules using the Azure Portal, PowerShell, or Transact SQL statements. To create server-level IP firewall rules using the Azure Portal or PowerShell, you must be a subscription owner or contributor. To create a server-level IP firewall rule using Transact SQL, connect to the SQL Database instance as the server-level principal or AD administrator. Database-level IP firewall rules stored in individual databases allow the client access to specific secured databases within the same SQL database server. You can set database-level IP firewall rules for the master database and individual databases. You can only create and manage database-level IP firewall rules for master and user databases using transact SQL statements, and only after configuring the first server-level firewall. Suppose an IP address range in the database-level IP firewall rule is outside the range specified in the server-level IP firewall rule. In that case, only clients with IP addresses in the database-level range can access the database. You can't exceed the 128 database-level IP firewall rules limit per database. Best practices suggest using database-level IP firewall rules to boost security and increase your database's portability whenever possible. If you have multiple databases with identical access requirements, use server-level IP firewall rules for administrators to avoid configuring each database individually. Let's review. In this video, you discovered how firewall configurations can enhance data security, protect sensitive information, and help businesses focus on growth. You learned about implementing server-level and database-level IP firewall rules to block potential threats and prevent unauthorized access. You also learned how enabling Azure connections for internal applications allows access to only authorized personnel. Imagine you are a security engineer in a healthcare organization, and your organization uses Azure Structured Query Language Database, or Azure SQL Database, to store and process all the critical data. You receive an alert that a potential security breach has occurred on your network. It's suspected that an unauthorized individual may have accessed your database through malicious activity, and patient records are now accessible by unauthorized users. How would you capture and know the extent of that breach? You should be able to not only gain visibility into what's happening in your database, but also prevent malicious activity from occurring. Hello, and welcome to the video, Monitor Your Database. In this video, we will discuss some built-in features like auditing and advanced data security for Azure SQL Database to protect your database from any threat. Let us begin with understanding Azure SQL Database auditing. So, auditing allows you to store the operations that occur on your database for inspection and analysis. You can use auditing for compliance management or to understand your database usage. Auditing is also required to use Azure Threat Detection on your Azure SQL Database. This is the basic understanding of auditing. Let us dive deeper to understand how auditing benefits us. Firstly, auditing can be used to retain an audit trail of selected events by defining categories of database actions. Secondly, you can use auditing to report on database activity using pre-configured reports and a dashboard. Thirdly, you can analyze reports and find suspicious events, unusual activities, and trends. Audit logs are written to append blobs in an Azure Blob Storage account you designate. You can apply audit policies at the server level or database level. Once you have enabled the policies, you can use the Azure portal to view or send the logs to Log Analytics or Event Hubs for further processing and analysis. Generally, it's recommended that you enable only server-level blob auditing and leave database-level auditing disabled for all databases. You should avoid enabling both server blob auditing and database blob auditing together unless you want to use a different storage account or retention period for a specific database, or you want to audit event types or categories for a specific database that differs from the rest of the databases on the server. With this, let us conclude the concept of auditing and move on to another feature, advanced data security. Advanced data security provides advanced SQL security capabilities. We will also discuss data discovery and classification, vulnerability assessment, and advanced threat protection. So firstly, data discovery and classification provide capabilities built into Azure SQL Database for discovery, classifying, labeling, and protecting the sensitive data in your database. Data discovery and classification can be used to provide visibility into your database classification state and to track access to sensitive data within the database and beyond its borders. The second is vulnerability assessment. It can be easily configured and helps to discover, track, and remediate potential database vulnerabilities. It provides visibility into your security state and includes actionable steps to resolve security issues and enhance your database fortifications. The third is advanced threat protection. It detects anomalous activities indicating unusual and potentially harmful attempts to access or exploit your database. Advanced threat protection monitors your database for suspicious activities and provides immediate security alerts on potential vulnerabilities, SQL injection attacks, and anomalous database access patterns. Advanced threat protection alerts provide details of suspicious activity and recommend action on how to investigate and mitigate the threat. We have now come to the end of this video. Let's summarize what you learned in the video. Azure SQL Database auditing, benefits of auditing, advanced data security, along with data discovery and classification, vulnerability assessment, and advanced threat protection. Consider you are a cybersecurity administrator working for a financial institution, and your organization uses Azure SQL, frequently called Structured Query Language, database to store personal information about its customers. You understand the need to protect the data of customers. You know that by using auditing, the stored operations can be later used for inspection and analysis through automated tools. Therefore, you decide to enable database auditing using the Azure portal, as auditing will also help you meet compliance requirements and provide visibility and accountability into database events. Hello, and welcome to the video, Enable and Monitor Database Auditing. In this video, we will discuss configuring server-level and database-level auditing using the Azure portal. So, before starting with the steps to help you set up auditing on your system, let us revise the need for auditing. Auditing allows you to retain an audit trail of selected events. You can use pre-configured reports and a dashboard for activity and event reporting. You can analyze reports and find suspicious events, unusual activity, and trends. Did you know that auditing policy can be defined for a specific database or as a default server policy? A server policy applies to all databases on the server. So, if server auditing is enabled, it always applies to the database. The database will be audited regardless of the database auditing settings. Enabling auditing on the database or data warehouse, in addition to enabling it on the server, does not override or change any of the settings of the server auditing. In other words, in this case, the database is audited twice in parallel, once by the server policy and once by the database policy. Let us now discuss the configuration of auditing using the Azure portal. Firstly, sign into the Azure portal. Then, in the search bar at the top of the portal, search for your server name, then select the server in the portal. In the left menu pane, under Security panel, select Auditing. Auditing is turned off by default. To enable it on your database server, toggle Enable Azure SQL Auditing to On. After the On button is selected, select the Storage checkbox. Select your subscription. You can select an existing storage account or create a new storage account to store your audits. The storage account must be configured to use the same region as your server. In this case, we'll define a new storage account. Under Storage Account, select Create New. The Create Storage Account pane displays. Name the storage account and select OK. Leave all the other options at their defaults. Select Save in the toolbar to save your changes and enable auditing on your database server. As a practice, you can generate some audit records in the database and run some queries. Back in the portal on your SQL server, select SQL Databases in the left menu pane and select that specific database where the audit records were generated. In the left menu pane of that database under Security, select Auditing. Because we enabled auditing at the server level, you should see that it's also enabled at this location. Select View Audit Logs in the top menu bar to view the logs. You should see one or more audit records. One should contain the details of the query you executed. As shown in the figure, you might also see other events, such as authentication failures and successes. Select any record to see the full details of the event. These actions configure the audits of the database server level and will apply to all databases on the server. You can also configure auditing at the database level. Firstly, retain an audit trail of selected events. Report on database activity and analyze results. Configure the policies for the server or database level. Configure audit log destination. So, a new server policy applies to all existing and newly created databases. We have now come to the end of this video. In this video, you learned how to set up auditing on your system. Jasmine works as a database administrator in a financial institution. Her organization used Microsoft Azure Structured Query Language Database, or Azure SQL Database, to store customer data. The organization has recently become concerned about the security of its database and wants to enable advanced data security features to protect against potential risks. How will these features contribute to the protection of their database? Will it be a tedious process to configure these features? Hello, and welcome to the video Advanced Data Security for Azure SQL Database. In this video, we will discuss these features and their advantages. You will also learn how to configure these user-friendly features in your system. Let us start by understanding the concept of advanced data security. Advanced data security offers comprehensive security features specifically designed to protect your Microsoft Azure SQL database from security risks and malicious activities. Let us discuss 3 such features: data discovery and classification, vulnerability assessment, advanced threat protection. The first is data discovery and classification. As the name suggests, data discovery and classification provides capabilities built into Azure SQL Database for discovering, classifying, labeling, and protecting the critical data in your database. It provides visibility into the database classification state and tracks access to sensitive data. The second is vulnerability assessment and can be easily configured to discover, track, and help you remediate database vulnerabilities. It provides visibility into your security state and includes actionable steps to resolve security issues. The third is advanced threat protection, which detects unusual activities. It continuously monitors your database for suspicious activities and provides immediate security alerts on potentially harmful issues. It also recommends actions on how to investigate and mitigate the threat. How to configure these features? Let us start to learn that by enabling advanced data security on your database. Advanced data security is a server-level setting, so we will start there. First, sign in to your Microsoft Azure portal, then go to your SQL server. In the search bar at the top of the portal, search for your server name and select the server. In the left menu pane under Security, select Microsoft Defender for Cloud. After that, select Enable Microsoft Defender for SQL. Once you have enabled it, select Configure next to the message Enabled at the subscription level. The Server Settings pane displays. Periodic recurring scans is on by default. When a weekly scan is triggered, a scan result summary is sent to the email address you provide. Also send email notification to admins and subscription owners is enabled by default to send the threats to the service administrators. Select Save at the top to save your settings. Now, under Advanced Threat Protection Settings, add your contact details to the subscription's email settings in Defender for Cloud to open the Defender for Cloud email notifications pane. You can optionally define where notification emails will be delivered as a list of email addresses separated by semicolons. Also send email notification to admins and subscription owners is enabled by default to send the threats to the service administrators. Select Save to apply the changes. You will receive email notifications as vulnerabilities are detected. The email will outline what occurred and the actions to take. Moving on, go to your Marketplace database for data discovery and classification. In the search bar at the top of the portal, search for Marketplace and then select the database in the portal. After this, in the left menu pane under Security, select Data Discovery and Classification. The Classification tab shows columns within your tables that need to be protected. You should note that some of the columns may have sensitive information or might be considered classified in different countries or regions. A message appears if any columns need protection configured. This message will have number of columns with classification recommendations. You can select the text to view the recommendations. Select the columns you want to classify by selecting the checkmark next to the column. Select the Accept Selected Recommendations button to apply the classification recommendations. Next, you will edit the columns and then define the information type and the sensitivity label for the database. Select Save to save the changes. No active recommendations should be listed once you have managed the recommendations successfully. Let us move on to Security Vulnerabilities. In the left menu pane, under Security, select Microsoft Defender for Cloud. The Recommendations section lists configuration issues on your database and the associated risk. Select a recommendation. You will see the detail on the recommendation pane, such as the risk level, which database it applies to, a description of the vulnerability, and the recommended remediation to fix the issue. Apply the remediation to resolve the issues. You should make sure to address all the vulnerabilities. For security incidents and alerts, address issues by following the recommendations. You can work backward to where the query is executed for issues like SQL injection warnings. Once you have found it, you can rewrite the code to eliminate the issue. With this, we have come to the end of this video. In this video, you learned about characteristics and advantages of advanced data security features and configuration of advanced data security features. Rio is a database administrator in a healthcare organization, and his organization relies heavily on Azure Structured Query Language, or Azure SQL Database, to store customer information. His top priority is to ensure the security of the database and protect the confidentiality and integrity of the data. He wants to go for a service that is easy to set up and assists him with steps to eliminate security issues. Therefore, he chooses the Vulnerability Assessment feature to protect his valuable data from potential threats. Hello, and welcome to the video Explore Vulnerability Assessment. In this video, you will learn about the benefits of advanced data security for Azure SQL Database, specifically the SQL Vulnerability Assessment feature that bolsters your security measures. Let us start by defining Vulnerability Assessment. Vulnerability Assessment is a service that provides visibility into your security state. It also includes actionable steps to resolve security issues that enhance your database security. It assists you with monitoring a dynamic database environment where changes are difficult to track, improving your SQL security posture. So, Vulnerability Assessment is a scanning service built into the Azure SQL Database. The service employs a knowledge base of rules that flag security vulnerabilities, such as misconfigurations, excessive permissions, and unprotected sensitive data. What is the basis of these rules? The rules employed are based on Microsoft's best practices and focus on the security issues that present the most significant risks to your database and its valuable data. They cover database-level issues and server-level security issues, like server firewall settings and server-level permissions. Did you know you have the flexibility to customize the assessment report for your environment? You can do that by setting an acceptable baseline for permission configurations, feature configurations, and database settings. Setting up Vulnerability Assessment is a breeze. You can easily configure the service. It helps you to discover, track, and remediate potential database vulnerabilities. You can use it to proactively improve your database security for Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse Analytics. It is important to note that Vulnerability Assessment is part of Microsoft Defender for Azure SQL, a unified package for advanced SQL security capabilities. Vulnerability Assessment can be accessed and managed from each SQL database resource in the Azure portal. With this, we have come to the end of this video. In this video, you have learned in detail how Vulnerability Assessment functions and its benefits. Congratulations! You have successfully completed learning about authentication and firewalls and auditing and monitoring. It is time to quickly recap the concepts you have learned. You started with understanding the overview of database security. You explored how Azure Structured Query Language, or SQL Database firewalls protect the data. You learned that the server-level firewall rule allows traffic from specified IP addresses, while the database-level firewall allows access to specific databases. Other than this, you focused on Virtual Network Service Endpoints, or VNet Service Endpoints, which extend your VNet private address space and protect the identity of your VNet to Azure service resources, ensuring that only traffic from your VNet can access the databases. You learned how you can control who can access your database by understanding authentication, which is the process of verifying an identity. You discovered that SQL Database supports two types of authentications. One is SQL authentication, through which the user submits a user account name and associated password to establish a connection. The other is Azure Active Directory authentication, or Azure AD authentication, which helps the user submit a user account name and requests the service use the credential information stored in Azure Active Directory. You also learned that authorization refers to what an identity can do within Azure SQL Database by controlling granted permissions. You later learned to enable SQL Database authentication. Here, you explored more about SQL authentication and Azure AD authentication. You also discovered the flexibility of creating user accounts in the master database that grants permissions across databases. You also learned about the different security modes for authentication provided by SQL Server and MySQL, including the principle of least privilege and using dedicated accounts for application interactions. Lastly, you focused on the functionality of Azure AD authentication. You later learned about configuring Azure AD authentication in the Azure portal, which required the usage of SQL Server Management Studio as well. You also got an opportunity to reinforce your knowledge through a hands-on exercise, which helped you explore the configuration of Azure AD authentication in a detailed manner. Later, you learned about monitoring your database by focusing on auditing and advanced data features. You understood how auditing helps you to retain an audit trail of selected events. By using auditing, you can also analyze event reports and have pre-configured reports on database activity. Moving ahead, you learned to enable auditing, where you looked at the steps to take if you want to set up auditing on your system. In the process of enabling auditing, you also got to understand the steps to create a storage account. Later, you learned about auditing in practice. Here, you discovered how it is not recommended to enable server blob auditing and database blob auditing together unless you want a storage account or retention period for a specific database, or you want to audit categories for a specified database that differs from other databases. You then explored various advanced data security features and services for Azure SQL Database, including vulnerability assessment that helps to discover, track, and help you remediate potential database vulnerabilities, data discovery and classification that provides capabilities for discovering, classifying, labeling, and protecting the sensitive data in your database, and advanced threat protection that detects anomalous activities indicating unusual and harmful attempts to exploit your database. Here, you majorly focused on how to implement and configure these features and services for the security of your database. You focused on implementing data discovery and classification, where you learned how data is at rest, in process, and in transit, as well as structured or unstructured. You also learned the steps for discovery, classification, and labeling by exploring two metadata attributes, labels and information types. Later, you explored vulnerability assessment, where you understood the functionality of vulnerability assessment and its benefits. It helps you to discover, track, and remediate potential database vulnerabilities. You can use it to proactively improve your database security for Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse Analytics. Oh, what a fantastic learning experience that was! You are now ready to take the next step and handle the graded assessment for this module. Good luck with the module quiz.
ForMoney is a financial institution that decides to develop a website to facilitate the process for its customers. ForMoney wants to ensure that the website maintains the highest security posture. The organization plans to implement Microsoft Defender for Cloud to protect cloud and on-premises environments. ForMoney uses several parts to make the website hosted in a multi-cloud environment. It consists of Microsoft Azure, Amazon Web Services or AWS, Google Cloud Platform or GCP, and structured query language or SQL databases to store data. Let's understand how For Money will benefit. Hello, and welcome to the video. What is Defender for Cloud? In this video, we'll discuss various Defender plans and their purpose. Cybersecurity is a big concern for businesses that operate online. Multi-cloud environments bring a lot of advantages and benefits, but also expose your business and customers' data to cyber threats. To avoid any threats, every online business should ensure that the business has proper security and protect its workloads running in Azure and hybrid environments. So what is Defender for Cloud? Defender for Cloud is a software product that protects and secures your hybrid cloud environments in Azure, AWS, GCP, and on-premises environments. Did you know that Defender for Cloud provides you with recommendations to improve your security posture via a secure score? Let's understand what a secure score is and how it works. A secure score is a percentage-based key performance indicator that informs you about the security strength of your environment. The higher your secure score, the more secure your environment. The secure score is made up of various controls. These controls contain recommendations. You can increase your secure score or security posture by remediating all the recommendations and the controls associated with your environments. Your environments are hardened once you remediate the recommendations. This, in turn, improves your security posture across Azure, AWS, and GCP. Defender for Cloud secures your resources in your cloud environments through many Defender plans. Let's have a quick look at them. The first is Defender for Servers. The plan provides threat protection and advanced defenses to your Windows and Linux machines running in Azure, AWS, GCP, or on-premises environments. The second plan is Defender for Storage. It detects unusual and potentially harmful attempts that access or exploit your storage accounts. The third plan is Defender for SQL. The plan discovers and mitigates potential database vulnerabilities. It also detects anomalous activities that may indicate a threat to your database. Moving on, the fourth plan is Defender for Containers. This plan continuously assesses clusters and provides visibility into misconfigurations and guidelines to help mitigate identified threats. It also includes vulnerability assessment and management tools for images stored in Azure Container Registry. It generates security alerts for suspicious activities for clusters and Linux nodes. The fifth plan is Defender for App Service. This plan identifies attacks that target applications over app service. The sixth plan is Defender for Key Vault. It detects unusual and potentially harmful attempts to access or exploit Key Vault data. The seventh plan is Defender for Resource Manager. It monitors your organization's resource management operations, whether performed through the Azure portal, Azure Representational State Transfer Application Programming Interface or Azure REST APIs, Azure Command Line Interface or Azure CLI, or other Azure programmatic clients. The eighth is Defender for Domain Name System or DNS. It detects suspicious and anomalous activities such as data exfiltration, malware, DNS attacks, and communication with domains that are used for malicious activities. Some examples are phishing and crypto mining. The ninth plan is Defender for Open Source Relational Databases. It provides threat protection for Azure Database for Postgres SQL, Azure Database for MySQL, and Azure Database for MariaDB. The last one is Defender for Azure Cosmos DB. It detects potential SQL injections based on Microsoft Threat Intelligence, suspicious access patterns, and potential exploitation of your database through compromised identities or malicious insiders. All these plans are integrated into the Defender for Cloud service, each protecting your multi-cloud environment. This results in the implementation of multiple layers of security controls. Let's reconsider the example of For Money to understand how defense in-depth strategy will help the organization to protect its key assets. No security measure is enough to provide complete protection, so a combination of different plans is employed to create a resilient defense. For Money has its new website to maintain the flow of information between customers and the organization. You enable both Defender for SQL plan and the Defender for Servers plan, so the organization will be able to use Defender for Cloud Dashboard to monitor and configure protections and their workloads. If there are any threats, Defender for Cloud will use threat detection. Based on the results, Defender for Cloud will create alerts and recommendations. Now, these alerts contain metadata that lets you know which resources are affected and what occurred. Each alert also includes a Take Action section that guides you with remediation steps for the alert. Other than this, the Defender for Servers plan will also provide protections with alerts that are meant to protect your environment from threats, such as brute force attacks. With this, we have come to the end of this video. In this video, you learned about what is Defender for Cloud, various Defender plans, and an example to understand defense in-depth strategy. Imagine you're a security engineer at a large multinational organization that operates in a hybrid cloud environment. The organization has a combination of on-premises infrastructure and utilizes Microsoft Azure for its cloud services. To ensure the security of their cloud resources and maintain a strong security posture, they've implemented Microsoft Defender for Cloud. Let's understand how Microsoft Defender for Cloud works and what features it offers. Hello, and welcome to the video, How Defender for Cloud Works. In this video, we'll focus on various features and elements situated on the overview page of Defender for Cloud to understand how Defender for Cloud functions. Let's start by understanding Cloud Security Posture Management, also called CSPM. It's a proactive system by which organizations can identify and remediate misconfigurations, threats, misuse, and compliance violations across a multi-cloud infrastructure. Let's now explore Microsoft Defender for Cloud to understand how these capabilities are integrated and provided. The overview page of Microsoft Defender for Cloud is an interactive dashboard that provides a unified view of the security posture of your hybrid cloud workloads. Additionally, it shows security alerts, coverage information, and more. You can select any element on the page to get more detailed information. You can view and filter the list of subscriptions by selecting Subscriptions. Defender for Cloud will adjust the display to reflect the security posture of the selected subscriptions. What's New opens the release notes so you can keep up to date with new features, bug fixes, and deprecated functionality. High-level numbers for the connected cloud accounts show the context of the information in the main tiles and the number of assessed resources, active recommendations, and security alerts. Select the assessed resources number to access the asset inventory. Defender for Cloud continually assesses your resources, subscriptions, and organization for security issues. It then aggregates all the findings into a single score so that you can understand at a glance your current security situation. The higher the score, the lower the identified risk level. Moving ahead for workload protections, the Cloud Workload Protection Platform, also called CWPP, integrates within Defender for Cloud for advanced intelligent protection of your workloads running on Azure, on-premises machines, or other cloud providers. For each resource type, there's a corresponding Microsoft Defender plan. The tile shows the coverage of your connected resources and the recent alerts color-coded by severity. Defender for Cloud provides insights into your compliance posture based on continuous assessments of your Azure environment. Defender for Cloud analyzes risk factors in your environment according to security best practices. These assessments are mapped to compliance controls from a supported set of standards. The Asset Inventory page of Microsoft Defender for Cloud provides a single page for viewing the security posture of the resources you've connected to Microsoft Defender for Cloud. The Inventory tile provides a glance at the total healthy and unhealthy resources. All resources with unresolved security recommendations are shown in the inventory. You'll also have access to a software inventory if you've enabled the integration with Microsoft Defender for Endpoint and Microsoft Defender for servers. Let's revisit how regulatory compliance is handled by exploring the regulatory dashboard. Microsoft Defender for Cloud continuously evaluates your hybrid cloud environment to analyze the risk factors. The analysis takes place according to the controls and best practices and the standards that you apply to your subscriptions. The dashboard reflects the status of your compliance with these standards. The Microsoft Cloud Security Benchmark is automatically assigned to your subscription accounts when you onboard Defender for Cloud. It includes a collection of impactful security recommendations you can use to help secure your cloud services. Let's explore Microsoft Cloud Security Benchmark more. This benchmark builds on the cloud security principles defined by the Azure Security Benchmark. These principles are applied with detailed technical implementation guidance for Azure, other cloud providers such as AWS and GCP, and other Microsoft clouds. The Regulatory Compliance Dashboard gives you a view of your overall compliance standing. Security for platforms other than Azure follows the same security principles as Azure. Each control within the benchmark provides the same granularity and scope of technical guidance across Azure and other cloud resources. From the compliance dashboard, you'll be able to manage your compliance requirements for your cloud deployments, including automatic, manual, and shared responsibilities. Let's move on to Cloud Workload Protection, also called CWP. CWP is the reactive part of Defender for Cloud. Defender for servers sends alerts informing you about potential cyber attacks, such as brute force attacks. You could also set up automatic responses in case Defender for Cloud detects a cyber attack against your environment. These alerts are generated through Defender for Cloud's enhanced security features. Alerts are available on the Alerts page in Defender for Cloud. This page informs you about possible cyber attacks or malicious actions against your resources. With this, we've come to the end of this video. In this video, we learned about various features and elements of the overview page of Defender for Cloud, Along with this, we had a detailed view of regulatory compliance dashboard. Imagine you're a cybersecurity analyst for a retail organization. Your organization wants to develop a new e-commerce website in order to sell clothes online. Your responsibility is to ensure a robust security posture for your organization, so you plan to implement cloud plans. Let's understand what Defender plans will be the most appropriate to protect your organization's resources from security threats and malicious activities. Hello, and welcome to the video, When to Use Defender for Cloud. This video will explore the most appropriate Defender plans that can fortify your organization's security infrastructure. Before diving deep into this topic, let's revisit what a Defender for Cloud is. Defender for Cloud is a security software product that protects and secures your hybrid cloud environments in Azure, Amazon Web Services or AWS, Google Cloud Platform or GCP, and on-premises infrastructure. Let's move on to the criteria to help you decide which plan to implement. When you are choosing which plans to activate, you need to consider which resources your organization will use and what regulatory requirements your business may work under. To understand the concept, let's suppose your organization's requirements include the protection of its servers, the protection of its databases, and the remediation of issues that may arise. Let's start by discussing the first requirement. You know that the Defender for Server plan offers features such as advanced threat protection, vulnerability assessment, adaptive network hardening, adaptive application controls, and more. All of these features will work to strengthen your company's security posture and protect its servers. Therefore, this plan ensures the protection of your servers from potential security threats. Moving on, the next requirement is the protection of your databases. Each database may contain sensitive information that no company would want to be exposed to the outside world. Some examples of such information could be saved username passwords of your customers, along with their credit card information and home shipping addresses. The database can also contain profit reports and other financial information. To secure such sensitive information about your organization, Microsoft Defender plans are designed. The databases protected are structures query language or SQL, SQL on machines, MariaDB, MySQL, PostgreSQL, and Cosmos DB. Now, the third requirement is remediating the recommendations. Even if you're aware of misconfigurations in your security or potential risk factors and threats against your environments, you may need to learn how to fix them. Defender for Cloud offers a user-friendly solution for these situations. The Security Posture page shows you an overview of all your environments. The Recommendations page shows you all the recommendations and security misconfigurations associated with your resources. From here, you can find solutions that are easy to deploy or guidance on how to remediate the issues pointed out by the recommendations. Once you have selected the recommendation, you're presented with information explaining the severity level, a description of the issue, related recommendations, remediation steps and their quick fixes, if available, and a list of affected resources. Some recommendations have a quick fix button that you can select to automatically fix the issue on any of the available resources. The evaluation of your needs displays that Defender for Cloud can be the best fit for your organization. The ease of use with its varied coverage offers the best possible solution to provide protection for your multi-cloud environments. It has built-in capabilities that offer the best coverage for all types of resources. Also, if additional functionality is required, you can always add other plans according to your requirement. With this, we've come to the end of the video. In this video, you learned about when to use Defender for Cloud. You learned about evaluating an organization's needs by considering an example. You also figured out what kind of Defender plans can assist those needs. Imagine you're a cybersecurity analyst in a financial institution, and your organization relies heavily on Azure Structured Query Language Database, also called Azure SQL Database, for storing and managing critical information about the business. Your responsibility is to maintain robust security to protect the organization's database. To achieve this, you explore and enable Microsoft Defender for Databases plan. Let us learn how you'll enable Microsoft Defender for SQL Database. Hello, and welcome to the video, Enable Defender for SQL. In this video, you'll learn about the features and benefits of Microsoft Defender for SQL Database, how to enable Microsoft Defender for SQL, and how to manage Defender for SQL settings. Let's start by understanding Microsoft Defender for SQL and its features. Microsoft Defender for SQL is a Defender plan in Microsoft Defender for Cloud. The plan includes functionality for surfacing and mitigating potential database vulnerabilities. It detects anomalous activities that could indicate a threat to your database. It provides a single accessible location for enabling and managing these capabilities. Let's dive deeper into the benefits of Microsoft Defender for SQL. It provides advanced SQL security capabilities, including SQL Vulnerability Assessment and Microsoft Defender for Identity, formerly called Azure Advanced Threat Protection or Azure ATP. Let's revisit these concepts. Vulnerability Assessment is a service that discovers, tracks, and helps you remediate potential database vulnerabilities. It provides visibility into your security state and includes actionable steps to resolve security issues and enhance database fortifications. Microsoft Defender for Identity detects anomalous activities, indicating unusual and harmful attempts to access your database. It continuously monitors your database for suspicious activities and provides security alerts on potential vulnerabilities, Azure SQL injection attacks, and anomalous access patterns. Let's move on to understand how to enable Microsoft Defender for SQL. You can enable Microsoft Defender for all databases on your Azure server or your SQL managed instance with one select. There are also multiple ways to enable Microsoft Defender plans. You can enable it either at the subscription level or resource level. It's usually recommended to enable it at the subscription level so that all the new resources are automatically protected. If you want to manage the databases that need to be protected manually, disable them at the subscription level and enable each database you want to protect. You can enable Defender for SQL using Microsoft Defender for Cloud in the Azure portal or programmatically with the REST API, Azure CLI, PowerShell, or Azure Policy. Let's first understand how to enable Microsoft Defender for Azure SQL Database at the subscription level in Microsoft Defender for Cloud. From the Azure portal, open Defender for Cloud. From Defender for Cloud's menu, select Environment Settings. Change the plan setting to On once you have selected the relevant subscription. Select Save to enable the plan. Moving on, let's focus on enabling Defender plans programmatically. The flexibility of Azure allows several programmatic methods for enabling Defender plans. Have a look at some tools that enable Microsoft Defender plans. You've learned how to enable Microsoft Defender plans at the subscription level. Now let's focus on enabling Microsoft Defender for Azure SQL Database at the resource level. First, sign into your Azure portal and open your server. Under the Security blade, select Microsoft Defender for Cloud. After this, select Enable Microsoft Defender for SQL. You should note that a storage account is automatically created and configured to store your vulnerability assessment scan results. The existing storage account is used if you've already enabled Microsoft Defender for another server in the same resource group and region. You should also note that the cost of Microsoft Defender for SQL aligns with the Microsoft Defender for Cloud standard tier pricing per node, where a node is an entire server. Thus, you pay only once to protect all server databases with Microsoft Defender for SQL. Once enabled, how will you manage Microsoft Defender for SQL settings? To view and manage Microsoft Defender for SQL, sign into your Azure portal. Under the Security blade of your server, select Microsoft Defender for Cloud. Here, you'll be able to see the status of Microsoft Defender for SQL, whether it's enabled or disabled. If Microsoft Defender for SQL is enabled, select Configure to edit the settings for Microsoft Defender for SQL. You can make the necessary changes in the server settings. With this, you've come to the end of this video. In this, you learned about features and benefits of Microsoft Defender for SQL, including vulnerability assessment and Microsoft Defender for Identity. Next, we learned about enabling Microsoft Defender plans at the subscription level and enabling Microsoft Defender for SQL Database at the resource level. We also focused on managing Microsoft Defender for SQL settings. Imagine you're a data analyst working for a retail organization. Your organization handles sensitive customer information, including personal details and financial transactions. Your company must ensure the security and privacy of this data. Let's explore how you can use Azure Structured Query Language Database or Azure SQL Database features to secure your data. Hello, and welcome to the video, Secure Your Data in Transit, at Rest and on Display. In this video, you'll learn about various features offered by Azure SQL Database that help you secure your data at various stages. Let's start by learning how your data is secured in transit. Azure SQL Database enforces Transport Layer Security Network Encryption or TLS network encryption for all connections. This ensures that all your data is encrypted in transit between the database and the client. So how will this encrypted data benefit you? By using TLS encryption, you can ensure that anyone who may have intercepted this traffic between the app server and database will not be able to read the data. In simpler terms, TLS encryption is a standard for securing traffic over the internet and ensures your network traffic to and from Azure SQL Database. Next, let's learn about how your data is secured at rest. Azure SQL Database protects your data at rest using transparent data encryption, also called TDE. TDE performs real-time encryption and decryption of the database, associated backups and transaction log files at rest without requiring changes to the application. Using a database encryption key, transparent data encryption performs real-time input-output or I/O encryption and decryption of the data at the page level. Each page is decrypted when read into memory and then encrypted before being written to disk. By default, TDE is enabled for all newly deployed Azure SQL databases. It's important to check that data encryption hasn't been turned off. Note that older databases may not have TDE enabled. Let's look in the portal at where TDE is configured on your marketplace database. Sign into the Azure portal and search for your marketplace database. After selecting the database in the portal, you'll find transparent data encryption under the security blade. In the data encryption option, verify that data encryption is set to on. You will also see an encryption status as encrypted. Because new databases are encrypted by default, we can be sure that our data is encrypted on disk as soon as we create the database. Note that Azure includes Microsoft Defender for Cloud, which gives you visibility into the security of your environment, including Azure SQL databases. Microsoft Defender for Cloud flags any database that doesn't have TDE enabled on them. This gives you the ability to report and take action to secure your data. Let's move on to the next concept, securing data on display. When we run a query, there are phone numbers, email addresses, and other information that we may not want to fully display to everyone with data accessibility. Or we may not want our users to be able to see the full phone number or email address instead. We would like to display a portion of the data available for customer service representatives to help them identify a customer. Dynamic data masking is a policy-based security feature that can limit the data that is displayed to the user and hide sensitive data in the results set of a query over designated database fields, while the data in the database is not changed. Data masking rules consist of the column to apply the mask to and how the data should be masked. You can create your own masking format, or you can also use one of the standard masks, such as the default value to display the default value for that data type instead. Credit card value to just show the last 4 digits of the number, converting all other numbers to lowercase x. Email to hide the domain and all but the first character of the email account name. Number to specify a random number between a range of values, and customer string to set the number of characters exposed from the start of the data, the number of characters exposed from the end of the data, and the characters to repeat for the remainder of the data. Database administrators will still see the original values when querying the columns, but non-administrators will see the masked values. You can also allow other users to see the non-masked versions by adding them to the SQL users excluded from the masking list. Let's understand how data masking will work in the marketplace database. Sign into the Azure portal. In the search bar at the top of the portal, search for your marketplace database and select the database in the portal. In the left menu pane under Security, select Dynamic Data Masking. The Masking Rules screen shows a list of existing dynamic data masks and recommendations for columns that should potentially have a dynamic data mask applied. Consider this data. Here, the Masking Rules screen shows a list of existing dynamic data masks and recommendations for columns that should potentially have a dynamic data mask applied. Suppose you want to add a mask for the phone number that only displays the last 4 digits. Select the Add Mask button at the top to open the Add Masking Rule dialog box. You can select some values as shown in the image and select Add to add the masking rule. To understand it better, let's add one more rule for the email address. We'll repeat the same process and select the Add Mask button from the recommendations again to open the Add Masking Rule dialog box. Select Add to add the masking rule as it was done for phone numbers. Each new mask will be added to the masking rules list. Select Save to apply the masks. By running a query, your output will have masked values. Your data gets masked with the format that you specify. With this, we have come to the end of this video. In this video, you learned about how your data is secured when in transit, at rest, and on display by learning concepts like TLS network encryption, TDE, and dynamic data masking. Let's consider an e-commerce company that operates an online platform for selling various products. The organization collects and stores customer information, including personal details, payment information, and order history in the Azure Structured Query Language Database, or Azure SQL Database. To comply with data privacy regulations and ensure customer trust, the organization decided to implement dynamic data masking, also called the DDM feature. Let's understand how this feature will alter data visibility. Hello, and welcome to the video, Configure Dynamic Data Masking. In this video, we'll revisit the concept of DDM and explore the feature in detail. SQL Database DDM limits sensitive data exposure by masking it for non-privileged users. DDM helps prevent unauthorized access to data by enabling the designation of how much data needs to be revealed without impacting the application layer. Basically, DDM is a policy-based security feature that hides sensitive data in the result set of a query over designated database fields, keeping the data unchanged. So where do you find the need to use the DDM feature? The service representative at a call center can identify callers by several digits of their credit card number. Still, those data items cannot be fully exposed to the service representative. In such cases, a masking rule that masks all digits except the last 4 of any credit card number in the result set of any query can be defined. Similarly, a developer can query production environments for troubleshooting purposes without violating compliance regulations if an appropriate data mask is defined to protect personal data. Let's quickly revise to set up DDM. You can set it up in the Azure portal by selecting Dynamic Data Masking Operation in your SQL Database, Configuration, or Settings blade. You should note that this feature cannot be set up using the portal for Azure Synapse. Let's move on and understand specific DDM policies. First, a set of SQL users or Azure Active Directory, also called Azure AD identities, get unmasked data in the SQL query results. Basically, users with administrator privileges are always excluded from masking and can view the original data without any mask. Second, a set of rules defines the designated fields to be masked and the masking function to be used. So the designated fields can be defined using a database schema name, table name, and column name. The third and last policy is that a set of methods controls data exposure for different scenarios. The DDM recommendations engine flags specific fields from your database as potentially sensitive fields, which can be considered for masking. You can view the recommended columns for your database in the Dynamic Data Masking blade in the portal. With this, we've come to the end of this video. In this, we learned about configuring DDM and policies of DDM. Let's consider a financial organization's application that processes and stores sensitive financial information, including customer payment details, transaction records, and order information. To ensure the security and privacy of this data, along with compliance regulations, the organization has decided to implement transparent data encryption, also called TDE, which will be a crucial step. Let's understand how. Hello, and welcome to the video, Implement Transparent Data Encryption. In this video, we will revise the concept of TDE by exploring various concepts related to it, like service-managed transparent data encryption and customer-managed transparent data encryption related to it. Let's start by understanding how TDE assists you. It helps to secure the Azure Structured Query Language Database or Azure SQL Database, Azure SQL Managed Instance, and Synapse SQL in Azure Synapse Analytics from the threat of malicious offline activities by encrypting data at rest. TDE performs real-time encryption and decryption of the database, associated backups and transaction log files at rest without bringing any changes to the application. The real-time input-output or I/O encryption and decryption of the data is performed at the page level, which means each page is decrypted when read into memory and then encrypted before being written to the disk. So TDE encrypts the storage of an entire database by using a symmetric key called database encryption key, also called DEK. Now this encrypted DEK is decrypted and then used for decryption and re-encryption of the database files in the SQL Server database engine process. The TDE protector protects the DEK. The TDE protector is either service-managed transparent data encryption or customer-managed transparent data encryption. Let's explore TDE protector in detail. For Azure SQL Database and Azure Synapse, the TDE protector is set at the logical SQL Server level and is inherited by all databases associated with that server. For Azure SQL Managed Instance, the TDE protector is set at the instance level and is inherited by all encrypted databases on that instance. Kindly note that to simplify your understanding, the term server will be used for both server and instance throughout this video. Let's move on to service-managed transparent data encryption. In Azure, DEK is protected by a built-in server certificate by default. This built-in server certificate is unique for each server, and the encryption algorithm used is AES-256. where AES means Advanced Encryption Standard. Now, if the database is in a geo-replication relationship, the primary and the geo-secondary databases are protected by the primary database's parent server key. If two databases are connected to the same server, they also share the same built-in certificate. Microsoft automatically rotates these certificates in compliance with the internal security policy, and the root key is protected by a Microsoft internal secret store. Customers can also verify database compliance with internal security policies in independent third-party audit reports available on the Microsoft Trust Center. Microsoft also seamlessly moves and manages the keys as needed for geo-replication and restores. The second option to manage TDE is a customer-managed transparent data encryption, also referred to as Bring Your Own Key or BYOK support for TDE. Here, the TDE protector that encrypts the DEK is a customer-managed asymmetric key, stored in a customer-owned and managed Azure Key Vault, basically Azure's cloud-based external key management system, and never leaves the Key Vault. The TDE protector can be generated by the Key Vault or transferred to the Key Vault from an on-premises hardware security module device. SQL Database requires permission from the customer-owned Key Vault to decrypt and encrypt the DEK. If permissions of the logical SQL server to the Key Vault are revoked, a database gets inaccessible and all data is encrypted. With TDE with Azure Key Vault integration, users can control key management tasks, including key rotations, Key Vault permissions, and key backups, and enabling auditing on all TDE protectors using Azure Key Vault functionality. Key Vault provides central key management, leverages tightly monitored hardware security modules or HSMs, and enables separation of duties between the management of keys and data to help meet compliance with security policies. You've learned the detailed concept of TDE. Now let's quickly look at how you will manage TDE in the Azure portal. To configure TDE through the Azure portal, you must be connected as the Azure owner, contributor, or SQL security manager. You turn TDE on and off on the database level. To enable TDE on a database, go to the Azure portal and sign in with your Azure administrator or contributor account. Find the TDE settings under your user database. By default, Service Managed Transparent Data Encryption is used. A TDE certificate is automatically generated for the server that contains the database. For an Azure SQL Managed instance, use Transact SQL or TSQL to turn TDE on and off on a database. With this, we've come to the end of this video. In this video, you learned about how TDE is implemented along with Service Managed Transparent Data Encryption and Customer Managed Transparent Data Encryption. We also focused on how to manage TDE in the Azure portal. Always Encrypted is an Azure feature that safeguards important sensitive data, including credit card information and national and international identification numbers in SQL Database or SQL Server databases. With Always Encrypted, you can encrypt sensitive data inside your apps and keep encryption keys hidden from the database engine, whether SQL Database or SQL Server. The encryption creates a secure barrier between those who own and can view the data and those who manage it but shouldn't access it. Always Encrypted helps you store sensitive information securely, even if it's outside your control, by keeping database administrators or other high-privileged users from accessing encrypted data. Your data stays protected while stored and used in Azure, letting you delegate database management to third parties or lower the security clearance requirements for your DBA staff. Always Encrypted is designed to make the encryption process transparent to your apps. An Always Encrypted enabled driver on the client computer automatically encrypts and decrypts sensitive data in the app. The driver encodes the data in sensitive columns before it goes to the database engine and rewrites queries in a way that doesn't affect the app's functionality. Hello, and welcome to the video. Deploy Always Encrypted features. Keep your database always protected by using Always Encrypted. In this video, we'll dive into what Always Encrypted means in the context of Azure and SQL Server databases, its critical role in protecting sensitive data, how it makes the encryption process transparent to your applications, the different types of encryption it offers, and discuss scenarios to understand how to effectively implement this feature in real-life situations. Let's get started. First up, a few key aspects. Encryption and decryption. Always Encrypted makes encryption transparent to the applications. An Always Encrypted enabled driver installed on the client computer achieves this by automatically encrypting and decrypting sensitive data in the SQL Server client application. Encryption keys. The encryption keys used in this process are never revealed to the SQL Server or Azure SQL Database. Two types of keys are used in Always Encrypted: column encryption keys, CEKs, and column master keys, CMKs. CEKs are used to encrypt column data, and CMKs are used to protect the CEKs. Security. The architecture of Always Encrypted ensures your data remains encrypted at rest and during use, and increases the security of your data at rest and in transit. This architecture means that even database administrators, cloud administrators, or other high-privileged unauthorized users don't have access to the encrypted data. The database engine doesn't interact with plain text data stored in encrypted columns, but still allows some queries on encrypted data, depending on the encryption type for the column. Always Encrypted offers two types of encryption, randomized and deterministic. Deterministic encryption always gives the same result for any plain text. It's useful for point lookups, equality joins, grouping, and indexing on encrypted columns. It could, however, allow unauthorized users to guess data about encrypted values by examining patterns in the encrypted column, especially true if there's a small set of possible encrypted values like true, false, or regional directions like north, south, east, west. Deterministic encryption must use a column collation with a binary 2 sort order for character columns. Randomized encryption encrypts data less predictably, making it more secure. However, it prevents searching, grouping, indexing, and doesn't allow joining on encrypted columns. Now let's take a look at a couple of usage scenarios. On-site client with data in Azure. Imagine a business running an on-site application that works with sensitive data stored in a database hosted in Azure, SQL Database or SQL Server running on a virtual machine on Microsoft Azure. They keep the encryption keys in a trusted on-site key store and ensure that Microsoft Cloud administrators can't access sensitive data using Always Encrypted. Client and data both in Azure. Now consider a business with a client application hosted in Microsoft Azure. They store their sensitive data in a database hosted in Azure SQL Database or SQL Server running on a virtual machine on Microsoft Azure. While Always Encrypted can't completely isolate data from cloud administrators, since both data and keys are exposed to the platform's cloud administrators, however, the data remains encrypted in the database, so it does help reduce the potential security threats. Best practices suggest using deterministic encryption for columns used as search or grouping parameters like ID numbers. For data such as confidential comments not grouped with other records or used to join tables, randomized encryption is the appropriate option. Also, Always Encrypted might be considered a partial solution for data security. To create a more layered defense, use Always Encrypted with other SQL Server security features, such as transparent data encryption, TDE, and dynamic data masking. Time to recap. In this video, you learned how Always Encrypted protects sensitive data, the roles of encryption keys, and the implications for data security at rest and in use. You gained insights into two types of encryption, deterministic and randomized, explaining their applications and potential risks. You also discovered how Always Encrypted can be implemented for on-site and Azure-hosted clients, and explored best practices, emphasizing the importance of using Always Encrypted in conjunction with other SQL Server security features to build a robust and comprehensive defense system for data security. With the vast adoption of cloud-based databases today, protecting data stored in your Azure SQL Database, Azure SQL Managed Instance, or SQL Server, and ensuring it remains secure and confidential has never been more critical. Always Encrypted is a robust encryption feature designed to safeguard sensitive data, such as identification and credit card numbers, and other personal information. It enables data encryption within your applications, prevents the exposure of encryption keys to the database engine, and effectively separates data managers and owners. Imagine you work for a healthcare organization, MedHealth Inc., that stores patients' electronic medical records in a cloud-based SQL database. These records contain highly sensitive information, including medical history, diagnoses, and personal identification details. MedHealth has tasked you with meeting the need to ensure the utmost security of this data, complying with strict privacy regulations such as HIPAA. To address these requirements, you decide to implement Always Encrypted to protect the sensitive patient data stored in the database. By configuring and deploying Always Encrypted, you can create a security layer that safeguards patient confidentiality and mitigates the risk of data breaches. Welcome to the video, Deploy an Always Encrypted implementation. Always Encrypted protects sensitive data stored in databases such as Azure SQL Database, Azure SQL Managed Instance, and SQL Server. In this video, we'll explore how to configure and deploy an Always Encrypted implementation, ensuring the security and confidentiality of your data. As you get started with Always Encrypted, you'll need to set up a few things in your database. These include creating special Always Encrypted keys, setting up encryption properties for specific columns in your database, and even encrypting existing data in those columns. However, you'll need to use client-side tools since some tasks can't be performed in transact SQL. Since the server never sees the actual keys or the sensitive data in plain text, tools like SQL Server Management Studio, also called SSMS, or PowerShell come in handy to perform these tasks. Here are a few of the more common tasks some of these tools can perform. Provisioning column master keys, also called CMKs, column encryption keys called CEKs, and encrypting CEKs with their corresponding CMKs, SSMS PowerShell. Creating key metadata in the database, SSMS PowerShell SQL. Creating new tables with encrypted columns, SSMS PowerShell SQL. Encrypting existing data in selected database columns, SSMS PowerShell. Let's take a look at the basic steps to deploy an Always Encrypted implementation. Design. First, you'll determine what data should be encrypted and select the correct encryption type. There are two types of encryption available, deterministic and random. Deterministic encryption always produces the same encrypted value for any given plain text input. However, the predictable sameness may affect security. It allows point lookups, equality joins, grouping, and indexing on encrypted columns. Randomized encryption encrypts data less predictably, offering more security but disallowing searches, grouping, indexing, and joins on encrypted columns. Provision column master key and column encryption key. Always Encrypted uses two types of keys. The CMK is a key protecting key used to encrypt the CEKs. CMKs are stored in a trusted key store such as Azure Key Vault, Windows Certificate Store, or a hardware security module. CEKs are used to encrypt data in selected columns. They're encrypted and can be provisioned via SSMS or PowerShell. Set up key metadata and configuring column encryption. After provisioning the keys, the next step involves configuring the encryption properties for the chosen database columns. You'll specify the information about the encryption algorithm and provision cryptographic keys used to protect the data in the columns. Encrypt database columns. The next step is to encrypt the data in the specified columns using the configured encryption. You can perform the encryption process using SSMS or PowerShell. If there's existing data in the columns to be encrypted, you'll need to encrypt it during this process. Develop and modify applications. Client applications need to be modified to work with encrypted data. You must use an Always Encrypted enabled driver to communicate with the database. The driver will automatically determine which parameters target encrypted columns and should be encrypted when an application issues a parameterized query. Validation and testing. Upon setup, validating and testing are crucial to ensure your implementation works as expected. You might inspect a few rows to verify the data appears as random characters, decrypt and re-encrypt the data to ensure the keys are working correctly, or confirm user access to the CMK and CEK as assigned. Let's review your takeaways. In this video, you explored securing sensitive data in Azure SQL Database, Azure SQL Managed Instance, and SQL Server using Always Encrypted. You found that Always Encrypted allows you to encrypt sensitive data within your applications, such as personal identifiers and credit card details, while keeping encryption keys concealed from the database engine. And we covered the importance of implementing Always Encrypted for data security and compliance with privacy regulations. You learned about the initial setup of Always Encrypted, which involves creating special keys, setting up encryption properties for specific columns, and encrypting existing data. Since you can only perform some tasks with Transact SQL, you discovered you may need client-side tools like SSMS or PowerShell. You also learned about the steps to deploy an Always Encrypted implementation, including data design, provisioning CMK and CEK, configuring column encryption, encrypting database columns, modifying applications, and validation and testing. Congratulations! Your study about Microsoft Defender for Cloud and data masking and encryption has been successfully completed. Let's quickly go through what you've learned. You were introduced to Defender for Cloud, a software product that protects and secures your hybrid cloud environments in Azure, Amazon Web Services or AWS, Google Cloud Platform or GCP, and on-premises environments. You also learned about the Secure Score, a percentage-based key performance indicator that informs you about the security strength of your environment. You got a chance to catch a glimpse of various Defender points. You also learned how defense and depth strategy works by combining different plans to create a resilient environment. Some plans that you learned were Defender for Servers, Defender for Storage, Defender for SQL, Defender for Containers, Defender for App Service, Defender for Key Vault, Defender for Resource Manager, Defender for Domain Name System or DNS, and Defender for Azure Cosmos DB. After being introduced to Defender for Cloud, you learned how it works by understanding various features including subscriptions, what's a new column, high-level numbers, and assessed resources. You also looked at the security posture tile, workload protections tile, regulatory compliance tile, and asset inventory tile. You've got to understand the Microsoft Cloud Security Benchmark, which includes security recommendations to help secure cloud services. After understanding the functionality of Defender for Cloud, you focused on the basic and enhanced features of Microsoft Defender for Cloud. You've understood capabilities that secure cloud applications like code pipeline insights. You also learned some capabilities like centralized policy management, secure score, and multi-cloud coverage that improves your security posture. Other than that, to protect cloud workloads, you learned capabilities such as protecting cloud servers, protecting cloud databases, protecting containers, and security alerts. Here you learned what problems these capabilities can solve and how you get started with them. Next, you learned about when to use Defender for Cloud. Here you understood the need to implement various Defender plans by considering the resources your organization will use and the regulatory requirements your organization may work under. After understanding Microsoft Defender for Cloud, you focused on enabling Microsoft Defender for Structured Query Language, or SQL. You learned about the features and benefits of Microsoft Defender for SQL, which included vulnerability assessment, and Microsoft Defender for Identity, or Azure ATP. You also learned to enable Microsoft Defender plans at the subscription and resource levels. Once you understood how to enable Defender for SQL, you learned to manage Microsoft Defender for SQL settings in the Azure portal. Your knowledge was not just restricted to understanding the concepts, you got to apply your skills through a hands-on exercise where you focused on enabling Defender for SQL. Moving on to data masking and encryption, you learned to secure your data at various stages. You initiated knowing how your data is secured when it's in transit. You were introduced to Transport Layer Security Network Encryption, or TLS network encryption, a standard for securing traffic over the internet. TLS also ensures your network traffic to and from the Azure SQL Database. Next, you learned how your data is secured at rest using Transparent Data Encryption, or TDE. TDE performs real-time encryption and decryption of the database, associated backups and transaction log files at rest without requiring changes to the application. You also focused on securing your data on display using Dynamic Data Masking, or DDM. DDM is a policy-based security feature that limits the data displayed to the user in the result set of a query. After learning these concepts, you learned how to configure DDM. You also got to know the policies of DDM. That is, firstly, a set of users get unmasked data in the SQL query results. Secondly, a set of rules defines the designated fields to be masked and the masking function to be used. Thirdly, a set of methods controls data exposure for different scenarios. Next, you learned how to implement TDE along with Service Managed TDE and Customer Managed TDE, or Bring Your Own Key, or BYOK. Once you learned how to implement TDE, you were also able to manage TDE in the Azure portal. Moving on, you learned how Always Encrypted protects your data. You learned the role of encryption keys and their implications for data security at rest and in use. You learned that there are two types of encryptions. The first is deterministic, which always gives the same result for any plain text, and the second is randomized, which encrypts data less predictably, making it more secure. You learned that a proper Always Encrypted implementation is important for a secure database, so you focused on how to configure Always Encrypted in a database. Once again, you got the opportunity for a hands-on exercise where you practiced deploying the Always Encrypted implementation. That brings us to the end of this module. Wasn't that a valuable experience? You are now ready to take this learning journey ahead and handle the graded assessment for this module. Good luck with the module quiz.
Great job. You've reached the end of Course 5, Secure Your Data at Rest. In this course, you explored exciting topics and resources, including storage security, Azure Storage and Azure Files, database security and monitoring, and Defender for Cloud and data masking and encryption. In this summary, we will review these resources to help refresh your recall and reinforce your understanding. Let's get started. In week 1, you dove into shared access tokens. You learned about storage security and how it fits into the defense in depth strategy, a comprehensive security approach that layers measures to protect against threats. You learned that data sovereignty is subject to the laws of the country or region in which it's located. You also learn how to securely manage and configure Azure Storage access and provide secure access using authorization options. Then you explored shared access signatures, also called SAS. You learned how to deploy SAS to define specific permissions, duration, and resource access constraints. Then you generated SAS tokens in a hands-on exercise and assessed your learning in a knowledge check. Next up was shared keys. You learned that shared keys are access keys that are generated automatically when you create a storage account. You discovered these keys provided unrestricted access to a storage account's configuration and data, and learned the importance of securing and protecting them. You learned about test key rollover to verify the successful implementation of new keys, and that testing a key rollover is important to ensure new keys are generated, distributed, and applied without compromising security. You practiced test key rollover in a hands-on exercise and completed your knowledge check. Then came stored access policies. In an overview of stored access policies, you found they simplify permissions management, provide flexibility, enable SAS grouping, and provide fine-grained restrictions. You learn to create stored access policies, discovering they provide additional server-side control. You finish week 1 with an exercise to create a stored access policy, then demonstrated your knowledge in the module quiz. You began week 2, Azure Storage and Azure Files, by exploring Azure AD authentication for storage. You learned to manage Azure AD user account authentication. You saw how organizations manage and leverage Azure AD storage authentication and learned about the benefits of Azure AD storage authentication. You also learned about the key individuals and teams responsible for managing Azure AD storage authentication. Then, you participated in a hands-on exercise testing and configuring Azure AD user account authentication for storage. Following that, we introduced you to Azure Storage and Azure Files security. You learned that implementing storage service encryption provides enhanced data security for data at rest and in transit, regulatory compliance, and controlled access. You discovered how configuring blob data retention policies helps meet regulatory compliance requirements, ensuring immutable data is kept for a certain period, and how to apply policies at the container level, and saw the role of audit logs in tracking policy-related actions. You learned how to enable the secure transfer required property feature via the Azure portal and using coding tools. You saw its role in enhancing data protection by facilitating secure HTTPS connections for data transfers. Then you learned storage endpoints allow others to securely access data over a private link via a virtual network, VNet. You finished week 2 by securing a storage endpoint in a hands-on exercise and testing your knowledge in the module quiz. Week 3, database security and monitoring, started with authentication and firewalls and an overview of database security. You learned about Azure's database security features, including firewalls and virtual network service endpoints, authentication and authorization, data encryption, threat detection, and auditing. You learned about the key points in controlling access to your database, including ensuring data security and integrity, authentication, authorization. You learned how to enable SQL database authentication's 2 methods. SQL, also called Structured Query Language Authentication, involves entering a username and password, and Azure AD authentication securely verifies credentials from Azure AD. You explored configuring SQL database firewalls by establishing server-level and database-level IP firewall rules for access, discovering how firewall configurations enhance data security and protect sensitive information. Next up, in auditing and monitoring, you learned about monitoring your database, including auditing benefits, advanced data security, data discovery and classification, vulnerability assessment. You learned how to enable and monitor database auditing, and that you can use the dashboard and pre-configured reports for activity and event reporting. Auditing allows you to retain an event audit trail, analyze information, and identify suspicious events, unusual activity, and trends. You learned about advanced data security for Azure SQL Database and the built-in discovery and classification capabilities for discovering, classifying, labeling, and protecting critical data. You explored vulnerability assessments, finding they can be easily configured to discover, track, and remediate database vulnerabilities. You wrapped up week 3 by participating in the module quiz to assess your knowledge. As week 4, Defender for Cloud and Data Masking and Encryption opened, you discovered Defender for Cloud protects and secures hybrid cloud environments. You learned how it works, continually assessing your resources, subscriptions, and organization for security issues, and aggregating findings to understand your current security situation. You learn when to use Defender for Cloud by evaluating organizational needs and exploring Defender plans for your security infrastructure. You learn to enable Defender for SQL at the subscription and resource level and manage settings. You explored its features and benefits, including vulnerability assessment and advanced threat protection. Then you ran through enabling Defender in a hands-on activity and checked your knowledge in a practice quiz. Next, you explored data masking and encryption. You learned to secure your data in transit, at rest, and on display using Azure SQL Database features designed to help secure data at multiple stages and how your data is secured. You saw how to configure dynamic data masking, a policy-based security feature that hides designated sensitive data in query results, yet keeps the data unchanged, and how to implement transparent data encryption, or TDE, for real-time encryption and decryption. Next, you learn how to deploy Always Encrypted features and an Always Encrypted implementation. You learned its features to protect sensitive data and about encryption key roles. You learned the importance of implementing Always Encrypted for data security, regulatory compliance, and the initial setup, including creating special keys and encrypting columns and existing data. Week 4 culminated with a hands-on exercise, allowing you to practice deploying an Always Encrypted implementation, followed by the module quiz to test your knowledge. My goodness, what a fantastic lot you have learned. Pat yourself on the back, you have made it to week 5. Now, you are ready to complete the course project where you will put your learning into practice. You'll have a chance to provide significant and helpful feedback to your peers and receive that same feedback from them. After that, you'll participate in the graded assessment. Good luck. I know you're going to do great. Hey, experience the thrill of overcoming challenges once more and cherish your triumph. Graded assessments offer a way to validate your abilities and celebrate your development. Hello, and welcome to the video about the graded assessment. In this video, you will be introduced to important details related to the graded assessment at the end of this course. In this course, Secure Your Data at Rest, you would have learned all the concepts covered and successfully completed the hands-on exercises that reinforce your learning. Now, it is time for the final graded assessment. This assessment will test your understanding of securing your data against threats. The graded assessment assesses your knowledge and understanding of the concepts learned. It also helps you to sharpen your exam preparation skills, such as managing time efficiently and handling test anxiety. The graded assessments are designed to provide you with valuable insights into the area where you need to improve. You can apply these learnings to develop a firm exam preparation strategy for the AZ-500 certification exam. You might be curious about various aspects of the graded assessment, including the number of questions, the scoring methodology, and the duration of the exam. Let us dive deeper to understand the specifics. So what kind of questions can you expect in the final graded assessment? The final graded assessment consists of multiple choice questions. You will often be presented with a scenario that you must carefully analyze to answer the question correctly. You will notice that the question formats are similar to the knowledge checks and the module quizzes you completed. We have designed this question format to familiarize you with the pattern of questions encountered in the AZ-500 exam. Each question in the graded assessment carries a value of 1 point with a maximum of 20 points that you can earn. It is important to note that there is no negative marking for incorrect answers. Even if you are uncertain about a particular question, it's worthwhile to attempt it to the best of your ability. You do not need to hesitate to make an educated guess if required. What's the assessment duration? To ensure you have ample time to carefully consider each question and provide thoughtful responses, we have crafted the final graded assessment to last 1 hour, giving you approximately 3 minutes to answer each of the 20 questions. Note that you are under no pressure to complete the assessment within the stipulated time. There is no timer that will restrict you from continuing even if the allotted time has lapsed. Nevertheless, we strongly advise you to complete the assessment within an hour to practice for the pace expected in the AZ-500 exam. The graded assessment will allow you to navigate back and forth between questions and even modify your answers before your final submission. This feature will allow you to review your work, make required changes, and ensure that you are completely satisfied with your responses before the assessment. It is crucial to note that you must achieve a minimum score of 80% to pass the assessment. This means you will have to answer at least 16 of the 20 questions correctly. Take your time to carefully read each question before selecting your responses. As you prepare for the graded assessment, remember you can still revise the key concepts. Use this time to refresh your knowledge about storage security, data sovereignty, shared access signatures, and test key rollover. You can also revisit the concept of storage access policies. Other than this, it will be a good idea to review authorization and authentication, where you manage an authenticated Azure AD user account authentication. You can also go through the concepts of auditing and monitoring the database, where you learn about advanced data security features, including vulnerability assessment and data discovery and classification. Reviewing the concepts on Microsoft Defender for Cloud, Defender for Structured Query Language or SQL, and Microsoft Defender for Identity will be a good idea. You may remember that you have the option of taking the AZ-500 certification exam at a test center or from the comfort of your own home. To prepare efficiently for the AZ-500 certification exam, we recommend creating a similar environment for this graded assessment as well. This includes finding a quiet space to take the exam and closing all other applications and browser pages to simulate the exam environment. Best wishes with the final graded assessment of this course. Secure your data at rest. Congratulations! You have completed the course Secure Your Data at Rest. This is the 5th course in a series of 7 courses in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course is part of the preparation for the AZ-500 Microsoft Azure Security Technologies exam. The content you learned in this course aligns with the area of secure compute, storage, and databases. It also covers some aspects of managed security operations area of the AZ-500 exam. Recall that you can expect 20 to 25% of exam questions from this area. By learning the content in this course, you have prepared well to answer questions on disk encryption. You have also been introduced to Microsoft Defender for Cloud for security management and threat protection. You learned about storage security by focusing on shared access tokens, shared keys, and storage access policies. You focused on Azure Active Directory or Azure AD authentication for storage, Azure Storage, and Azure Files security. Then you learned about database security by understanding authentication and firewalls, as well as auditing and monitoring. Later, you focused on understanding the concepts of Defender for Cloud and data masking and encryption. You have now moved one step closer in your preparation for the AZ-500 exam. Remember to refer to the Microsoft website to view the latest updates on the AZ-500 exam. Before you sign off from this course, you will watch a video on the next steps that you will take to proceed further in this training program. See you in the following video. You have reached the final video of the course, Secure Your Data at Rest. Pause for a moment to recognize and celebrate this extraordinary achievement. As a next step, you will be learning the course titled Manage Security Operations. This will be the 6th course in the series of 7 courses that prepare you for the AZ-500 Microsoft Azure Security Technologies exam. The course of Manage Security Operations will help you to learn about Azure Monitor and Security Operations using Microsoft Defender for Cloud and Microsoft Sentinel. Let us explore what this course will offer you. You will start by learning about configuring and managing Azure Monitor. In this, you will define and explore Azure Monitor key resources to keep watch on how all your Azure resources are performing and to trigger alerts in case there is any problem. You will get to focus on various monitoring options available to you, where you will learn Microsoft Defender for Cloud and Microsoft Sentinel. You will get the 2 fundamental types of data, metrics and logs. Going further, you will learn why you should use full stack monitoring in Azure. You will also learn the need to monitor your applications, infrastructure, and Azure platform resources. Later, you will understand how to configure and monitor metric logs. In this process of learning, you will also understand how to enable log analytics. So what's next? You will learn about Azure Monitor Alerts, where you will learn about responding to critical situations, where you will focus on different alert rules for a response and common alert schemas. You will also focus on learning how to enable Azure Monitor Alerts. Once done with this, you will also get a chance to learn about tenant logs and resource logs. You will focus on enabling and managing Microsoft Defender for Cloud, which is a central location for setting and monitoring your organization's security posture. Here, you will get to know about customizing Microsoft Defender for Cloud by focusing on Defender plans, Azure subscriptions, auto-provisioning, among others. You will also learn to manage centralized policies with Microsoft Defender for Cloud. You will get to learn about configuring security center policies and recommendations. Later, you will discover about Secure Score, which has two main goals of helping you understand your current security situation and helping you efficiently and effectively improve your security. Moving further, you will know what a brute force attack is. It is a type of hacking technique in which an attacker tries to gain access to a network or system by guessing the username and password combination through an automated process. You will also learn how just-in-time virtual machine access or JIT VM access can protect you from brute force attacks. Then you will discover Microsoft Sentinel, which is a scalable cloud-native security information event management and security orchestration automated response solution. You will also learn how to enable Microsoft Sentinel. Moving further, you will learn about threat detection and data analysis by creating workbooks to explore Sentinel data. In this process, you will learn to enable rules to create incidents and even create customer analytics rules to detect threats. You will learn what automation rules and playbooks are. You will also learn about mapping entities in Microsoft Sentinel. Lastly, you will be learning to investigate and hunt potential breaches with Microsoft Sentinel. You will be coming across threat modeling tool that allows software architects to identify and mitigate potential security issues early. Now, after grabbing these skills, who would not like to try out things themselves? The Secure Your Data at Rest course provides you with practical skills through hands-on exercises. For example, the course provides step-by-step instructions on exploring Azure Monitor, enabling log analytics, implementing Microsoft Defender for Cloud, configuring security center policies, and investigating threats. We have come to the end of this video. In this video, you'll learn that your next step is taking the 6th course in this training program, Manage Security Operations. Are you ready to take your Azure security skills to the next level? See you in the next course.